Good morning, everyone. I am your host Ajit Singh Rena, and I am super excited today to kickstart Open Source Community Conference 2022. I would like to thank each one of you who has joined today for the seventh OSCONF event. This is an open event happening in collaboration with the leading global Meetup community all across the globe. In case you are attending this conference for the first time, just to let you know that OSCONF is powered by the Collabnix community. This is our seventh OSCONF event. We organized our first event in the month of April 2020, around 2 years ago, and ever since we had 100 plus speakers, 50 plus volunteers from different communities, and we attracted over 60,000 YouTube visitors on our community channel. Collabnix is not a company, but purely an open community of around 7,400 plus DevOps engineers. The community was built with an intention to construct, collaborate, and contribute. That means that we are here to help you out. We are we are here to help you succeed, right? I would like to thank each of our speakers who worked really hard and find their free time to submit their CFP. Today, they will be spending time with you to share their knowledge. There were plenty of exciting talks which were going to happen today. Out of those 35 CFPs, we have selected these 12 to 13 talks ranging from Docker to Kubernetes to CI/CD and DevSecOps. We are going to hear from experts, learn from each other, and of course, you are going to see some amazing demos from our speakers. So based on the community ask, this year we are streaming this event to YouTube as well as LinkedIn account. Secondly, I would like to thank our community partners. Thanks to official Docker Bangalore community, JFrog, and Middleware for their continuous support in making this happen. Our community has been continuously growing year over year. I still remember our community Slack with around 50 members in the year 2018, and now it has grown massively to 7,400 members. This year, we involved in a lot of giving back to the community. If you look at the contribution, this year Collabnix community members contributed to the projects like Docker tools, Kube tools, and Docker extensions. I would like to thank Mansi Mishra for being an active contributor to Docker tools. I also would like to thank the maintainers of Docker extension, Karishma Gupta and Subendu, for their tireless effort. Thanks to Apurva for keeping the Kube tools alive and keeping and getting it improved day by day. We launched a new repo called Docker Community Extensions and helped Docker in curating the list of new extensions. Thanks again to all our volunteers and contributors for their exciting GitHub repos. I would also like to thank Sangam, Apurva, Rohit, Raju for their continued support and contribution to meetups, blogging, and community support. These are few of the links which you can go ahead, look into it, and learn how to contribute if you are completely new to this community. Now, without any further delay, I would like to thank each one of you for attending today conference event. Sit back, relax, and hear from the industry expert. Thank you. Okay, with this, I'm going to invite our first speaker, Nicholas Frankel. He is a developer advocate with 15 years of experience. He's expert in Java, Java E, and Spring technology. Today, he's here to talk about chopping the monolith. Over to you, Nicholas.
Hi folks, thanks to be here for this talk about chopping the monolith. I'm Nicola Frankel, I've been a developer for a long time, and since a couple of years I work as a developer advocate. Right now I advocate for the Apache API 6 project, which is an API gateway built upon Nginx with OpenResty on top and with a lot of out-of-the-box plugins. I will use Apache API 6 in my demo, but this talk is not about Apache API 6, so you are free to choose any gateway you want. Disclaimer, this talk might contain a lot of controversial views, and you are welcome to disregard any of them. The state we are in right now is very interesting, because on one side, we see a lot of people advocating for using microservices, in my opinion, for the wrong reasons. And on the other side, we see monolith viewed as something bad. I mean, the word monolith itself has taken up a negative connotation, which I believe is not completely justified. So I would like first to dive a bit into what is a monolith, but much more importantly, what are microservices and the reason they came to be used. I will use a lot of Martin's follow definition because, like, he's a respected figure and it's not very controversial what he says. It's he plainly states facts, and so we can reuse them without much debate. So here I let you read the definition of Martin's follow microservices on his own Blicky. I'll leave you a couple of seconds to do that. And the gist of it is, well, you have each microservice running in its own process. That's the gist of it. And in the same article, he goes on to follow a couple of characteristics of microservices. And the interesting thing about those characteristics is that they happen at different, let's say, levels. So for example, some of them are very technical, some are more organizational. And let's play a game. I know that we are not interacting, but please think whether you are using microservices or not in your organization. Okay, now that if it's done, and if the answer is yes, you can go through each item and check whether it's the case or not. So are you if you are doing microservices, are you using componentization via services? Is each of your service organized around business capabilities? And so on and so forth. And at the beginning, they are more technical approaches, and I believe everybody implement them if you are doing microservices. However, at the bottom, there are two parts that are more organizational. And the most important one is product over projects. If you are doing microservices, you are not designing projects, you are designing product. The difference between a project as a start date and an end date, and you have a budget that needs to be spent between those 2 points, whereas a product has a start date, but there is no end date at the beginning. There will probably be an end date at some point when you retire the product, but you don't think about it, you don't plan for it, and the budget is probably recurring over several years. And that's the problem. A lot of people who claim they are doing microservices, they are still doing projects and not products. Hence, there is not many chance a lot of people among you are really doing microservices. In general, when I do this talk in a room of 50, I ask people who are doing microservices. There is half the room that raise their hand, and when we apply all those characteristics, in the end, there is probably 1 or 2 persons still doing that. So 1 or 2 person in general, that's the biggest problem, the product side. Okay, but it doesn't stop at that. When I started to read about microservices, a lot of people, a lot of the advocates of microservices were keen to point out Conway's law. And Conway's law is very simple. In his thesis, he stated that the architecture of an information system reflects how the company, the organization, is itself structured. So the idea is that if you start with a normal organization with, let's say, UI specialists and middleware specialists and DBAs, you will probably end up with a layered architecture because you will have each team doing their own stuff. So if you want to have microservices, then you should probably change your organization to have autonomous, independent teams. And for example, Amazon Web Services is a poster child for microservices because Bezos himself like told, hey, we have these 2 pizzas team. So basically we have team that can be fed with 2 pizzas. And it means they are like small and of course implying they are autonomous and independent. But my beef is that actually a very, very few organizations are like that. It's probably the case for like 1% or 0.5% of the organization, because most legacy organizations are designed around silos. So at the top, you've got the CEO, then you have the CTO, then in general, under the CTO, you have developer and operation, and in developer, you have like dedicated team, and in operation, you have other team, then you have that silo between like dev and ops, so that's the reason for the DevOps. And again, in each like team, in the development team, you probably have a manager that manages the planning, the schedule, that gives out tasks, that handles the gyros, whatever. And it's very hard to move from like such an organization designed around like silos to teams that are autonomous and independent. And the biggest problem, of course, are if you have a manager for each layer, for each like old legacy like silo, what do you do with them in the new organization? I always joke, and it might not be such a joke, that if your manager is like responsibilities is like to accept your vacation requests, to be a proxy for the pay raise each year, because let's face it, you cannot negotiate, it's just like a top-down decision, and do some reporting, then probably I don't need a manager, because I'm more already oriented toward the self-autonomous team. I know what to do. You give me a goal and I will achieve it. I don't need to be micromanaged. And actually, probably if you are working in an organization with manager, either they micromanage you, then they work a lot, but they don't add any value because you probably know better than them what you should do, or they leave you free, or then probably again they don't have a lot of value, because we go back to the accepting vacation request and being a proxy and reporting. Manager have a lot of value when they actually remove the roadblocks into removing removing any impediment you have toward your task. Otherwise, not that much. And so we get back to this issue where actually the biggest help into transforming a legacy organization into a microservice based organization is the middle management. And they are the ones that have the most to lose, because they won't have any place in the new organization. So it's a pretty bleak picture. But the problem is that in most microservices implementation, it starts with the technical side. You've got a technical person, probably very senior, and they read about microservices and they see all the benefit and they say, oh, I have all this problem in my architecture, in my organization, microservices seems to solve them. Okay, let's do that by the book, and we will remove transactions and we will have sagas and whatever. And then at some point, of course, the organization is not made for that. The organization is not designed for that. There will be a mismatch because of Conway's law. So you will end up in a situation you will have all the downsides of microservices and none of the benefits, which doesn't work that well. At that point, in general, the person who had the bright idea to implement microservices has already left for another job. And of course, they didn't forget to put microservices on their resume because, it's super shiny. And the problem is that our industry is an industry where we are supposed to have technical people, logical people, engineers who generally take decisions based on facts. However, my experience has shown me that most of the time, it's more like a herd of sheep following somebody who say, hey, like follow me, I have the solution for every one of your problem, and we are following. And it's not that great. Also, not to mention the fact that probably a lot of people want to put some line on their resume. And as an anecdote, like 15 years ago, I worked on a I didn't work on a project, but I worked in a place where the project next to me, they were implementing EGB3. And at the point EGB3 was like state of the art. The problem is that at this moment, there were no application servers, like production grade, let's say, based on some big companies like IBM, for example. And IBM was the normal provider of technologies in this organization. The product was not ready to run EGB3. So basically, the architect decided, hey, we will use EGB3 so that he could write it down on their CV. And it was not implemented in real life. There was no production application server ready to run EGB3 at that time. And so I don't know what happened, but that's a poster child for a very, very wrong decision. So why are people still doing microservices? If microservices are not the right thing, why are people still using it? Well, in another one of his articles, Martin Fowler describes a couple of benefits. Of course, there are costs, and we won't tell about the cost because I believe that nowadays everybody knows about the cost. He lists a couple of benefits, and there are three main benefits: strong module boundaries, independent deployment, and technology diversity. So let's talk about them each in turn and see what is the real benefit. So a lot of people say, hey, now if you implement microservice, of course, then you have a strong boundary between service, then you cannot reuse, or let's say, it should prevent you as much as possible from reusing the code from each other and then having entanglement in your code base. And that's true. But actually, there are other ways in each different tech stacks to implement those strong module boundaries. For example, in Java, you can have Java modules, or you can have let's see, there are some ways to say, hey, this package should depend on this package and not on this package, and then have an engine that checks that those rules are respected. And you can have your dependency graph between packages, and you can see it a lot. Of course, it will be after you have actually implemented the code, but with some discipline, it will work in exactly the same way. And again, if you want it to be at compile time, just implement Java modules and you should be done. In each tech stack, you probably have the same ways to do that. So other ways to do it, and with much less problems to boot. So it's probably not the right reason. It's a benefit, but it's not the reason. Technology diversity. Well, if you have microservices, of course, you can implement each of the service with their own tech stack. So you can have a Python microservice, a Node.js microservice, and aside a Java microservice. Everybody will be happy. And when I mean everybody, that's probably every developer, because then every team can choose their own technology, what they like the most. The problem is it works at the level of the team or at the level of a person, but probably not at the level of organization. Because if you have an organization of 200 people that really have already trouble recruiting good developers in one single tech stack, how would you recruit more developers in other tech stacks? I don't believe that you can take a Python developer and presto, you make it into a Java developer and vice versa. I'm a Java developer. I know Kotlin quite well at the moment, but I can write Python scripts. I'm unable to be a good Python developer. I lack too many years of experience. I can be a junior one. I cannot be a senior Python developer. I will probably write code that works, but not code that is Pythonic. And so for this reason, again, not the best of reason. However, I think that independent deployment is the real reason. It's the real benefit. And you might have heard about lead time, which is one of the golden metrics of DevOps. So if you have a project and it starts with the idea from the business and it ends with the deployment into production, you probably have those three phases like specification and implementation and deployment. So specification starts with the idea of the business until you've got the whole set of specifications. And to be honest, it's hard to do anything about it. It involves a lot of communication with the business. Depending on the maturity, you might have a lot of feedback loops. Right now, if you are doing Agile, probably you have a lot by design because the business doesn't know, and actually that's pretty true. However, when we want to deploy more rapidly, we probably want to shorten the implementation and deployment phase, and those two are the lead time. And this problem of deploying more frequently or deploying faster, it's not a new problem. We already had it back in the days. As I mentioned, I've been doing IT for nearly 2 decades, no more than 2 decades. And so I actually can vouch for the fact that we handled it before. So let me get back to it. So perhaps you have gray hair like me. If not, please bear with me because it will sound super funny. So back in the days, we didn't release frequently because releasing frequently would need, every time you would need to test the whole stuff. And we didn't have automated tests, or at least perhaps some unit tests, but no integration tests. So a lot of it was manual testing, and through manual testing, it cost a lot of time, a lot of resources. It tires the testers, and testing everything too frequently is not feasible. So we had a couple of releases per year, let's say 4 of them. And those releases were called release trains. And so the idea was you would design your code or your project so that it would fit at the date of the release train. And if you missed the train because your developers were too busy, too late or whatever, then you would need to wait until the next train. So if you deploy 4 times per year, it means that if you cannot ship a feature in train, you need to wait 3 months. And for the business, 3 months is a long time. So you were not allowed to miss the train. There was a lot of pressure to deliver on time, even if it was half finished, because the trick was you could send a bug fix directly to production without doing the whole testing, whatever. So the trick was actually to pretend to have finished one feature, and then of course it was not completely ready, or you knew it contained bugs, but then you could send the bug fixes afterwards. And sometimes it was even worse. You had a not finished design feature at all, but you would negotiate with the release manager that, hey, it was a bug fix, and it was again a lot about organizational issues. And though, as I mentioned, it's not possible to release often and test monolith well. You cannot do everything at once. It's not possible. And for this reason, release trains. Now let's focus on what I believe is the real problem. I believe that yes, some parts of the code do change frequently, or at frequency you cannot fathom. It can be because of laws. Laws you cannot plan for them, they will just happen. Of course, if you are a big organization with a lot of money, you can influence the laws, but I'm talking about regular organization. Regular organization, their software can be impacted without any influence from them because of laws. Sometimes it's because of the business that say, hey, I want this to change, and I want this to change, and the same thing over and over. And I believe that every software has parts that change with different pace. Some parts are very stable. Some parts are very unstable. And with a bit of habit, people who work on the code base, they know it. So again, let's say to like be easy, ports that like very, very rarely change and ports that change very often. And in the past, to handle the fast changing pace without redeploying everything, we had something called rules engine. And with rules engine, this is the definition of Wikipedia, you actually had code that was explicitly separated from the main application code. And so you released once, so there was no release, and then the business had an interface to change the rule directly in production, and they could do it whenever they wanted. And of course, with great power comes great responsibility. That was their responsibility who handled changes. And if they did write some bugs, it was their problem. But I don't believe that rules engine are like the solution. It's one of the solutions. For example, once I didn't like work on any like rules engine implementation, but I had the occasion to like read the code of one once because I was curious. And actually, the code, the rule itself was so complex that if you were not a developer, you had no chance of changing it. So the idea that the business can do that on their own is, I think, a bit hard. And if you were not from the business, it was very hard to understand the business logic if you were a developer. So you had to have both skills at once. Nevertheless, I think that the idea that you have like different parts of the code that change at different paces, it's still very like solid. It's a fact. And so rules engine are one way to change that, to cope with that, but there are other ways. You can have microservices, you can have serverless, you can have anything you want. And in Chris Richardson microservices pattern, so Chris Richardson has written a book about microservices, how you can like implement everything from the technical side to implement microservices. And he has also designed a site where you have design patterns for microservices. He goes on to describe how you can like evolve from one monolithic architecture to one like microservices architecture. And he uses the strangling fig pattern that also was described by Martin Fowler. And the idea is that you start with a monolith and then you go on like chopping like every part until you've got a microservice architecture, like one by one. And the problem with that approach is that, of course, he's describing a microservice architecture. So in the end, there is no monolith anymore. And I believe it's perfectly fine to start with a monolith and to stop at any point where actually the fast changing part has been isolated, where the non-fast changing part can stay inside a monolith. Because again, microservices architecture, you need a dedicated organization for that. Not everybody is prepared or is like this. So imagine you have an application that actually is a monolith and you want to chop apart. This application is a web application. One of the ways to handle that is through an API gateway. So you could have like the whole application going to the monolith through the API gateway, and because in some parts, so some path would be actually be directed to the chopped path. Imagine an e-commerce shop. And the business, I've worked in e-commerce before, business want to push some product. It might be for a lot of different reasons, like too much stock or flagship product or high margin product. I mean, lots and lots of reasons. In general, you sell more and by lowering the price, so that the pricing should be very, very flexible. If you have a rules engine pricing, it works pretty well. If you have defined every parameter that could change. For example, you can say, hey, this is a flagship product. If this is a flagship product, then do something. The problem with rules engine is that the code from the main application should match the code from the rules. The parameters need to be defined in advance. If you come up with a new parameter, of course, then probably the monolith part needs to change as well. So pricing should be flexible. In that case, the rules engine might not be a great idea. So the idea is we set up an API gateway, we don't break the client will stay the same, and we can deliver flexible pricing without any issue. So for that, I have a demo. So here I'm in IntelliJ. I've set up everything in Docker Compose because it's the easiest way to show you something. Of course, you shouldn't use Docker Compose in production, but for this demo, it's good enough. So here I have a couple of services. I have the API 6 Apache Gateway. API 6 relies on etcd. It stores its configuration in this distributed key value store. You might have heard about etcd before. It's the same key value storage that is used by Kubernetes internally. So it's quite mature and very hard to break. Then I have my application, which is an e-commerce application. I will show it just afterwards. And everything is stored in a MariaDB database, but that's not really important. So let's try our application. Okay, so Docker Compose up. So now Docker Compose starts every container. I've containerized already the e-commerce shop. It's a Spring Boot application. This is not important, but everything is on GitHub, so you can check afterwards. And we will wait a bit until it has finished because it's a JVM. It takes a bit of time to start. And let's see for a couple of seconds. And yeah, it's done. So now we can go to the application. And here I've started the application. I go through the API gateway. And of course, the API gateway tells me, hey, we don't know this path. So the first thing I need to do is configure the API gateway to let it know about where it should forward this path. For that, I'm using Apache API 6, as I mentioned, and Apache API 6 as an admin API that is based on a REST API itself. So here I'm using a Docker image that should run on the same network as the Docker Compose. I'm using the curl image. So the idea is I'm not using curl directly, so I don't force you to install curl. If you have Docker, you can run everything. And there is the root API, and we will create a new one with put. We need to test the API key because changing the configuration is a highly critical operation. So we need to be authenticated, but since it's a demo, I'm using the default key. And now we can create like this. So in this demo, I will catch every URI and I will send it to the chop shop. I have one single node, so I need to have an algorithm, but since I have a single node, every algorithm would work. So I run the script, done. And now if we get back to the application, now we can see our shop. So we have a couple of products. We can set add to cart, a couple of products, and then we can check our carts. Now this part is interesting. This part is actually, sorry, I need to refresh. Yes, I have a single request. The pricing is embedded. So I have a single request to get the price. The price is computed on the back end, and when I receive the result, I receive the result with all the lines of the cart and the price in one JSON payload. What I need to do now is to start changing it so that instead of doing this, my client will receive the cart and the client will request to the application, to the monolith, hey, give me the price for this cart. So here is the pricing. As you can see, it's Kotlin. So I hope that my explanation will be good enough if you are not a Kotlin developer. Here I have a function, you pass it to cart and it computes the price and basically it just adds everything. But the idea is that you can change this logic. And this pricing is used here. So when I request the checkout, it will like compute, it will get the card itself plus the price of the card. Again, as I mentioned, everything is computed server side and everything is returned as one entity called checkout view. So now the idea is we need to change it a bit, and for that we will expose the pricing as an HTTP route. So now the checkout view just returns the card itself, but the pricing now is a dedicated HTTP route. So price will be like return when you call the price endpoint. We need to containerize it, so it will be version 1.3 of the container, and we will deploy it again. So Docker compose up. It recreates the chop shop, and normally at this point I should be good to restart the class loader. So here you can see the new version of the application is starting again. Couple of seconds because it's a JVM. And yes, now it has started. Now we can go back to the application. So now it's a new session. I've lost all my sessions, so I need to do the same as before. You can notice that here it's 1.3 and not 1.2. Same products, we can add everything to the cart and check the cards. And now again, I need to refresh because it caches the JavaScript. So if I refresh it, now the price is computed correctly, but there are two calls. The first one returns we get the content of the cart, and with the content of the cart, we call this price endpoint with the content of the cart. So the request contains all the lines of the cart and the response contains the pricing. Now, what we can do is next step, the final step, is actually to intercept this /price call, and instead of forwarding it to the monolith, we can forward it anywhere. I will be using a serverless function. So here I've created a JavaScript function. This JavaScript function, I've uploaded it to Microsoft Azure function. And there is this new change, so I will route it. I will create a new route, so a new one that only intercept /price, and that through a plugin, because API 6 natively understands how to talk with Azure, we can send it to a function array that I previously created. And I need an authorization token, and let's do that. So I can show you the Azure function. So here I'm on the Azure portal. I can go to function application. You see here I have the chop shop pricing, and if we check the code of the chop shop pricing, here is the function, here is the trigger, and we can see that the code that I've shown you in my IDE is the one that is displayed here. Again, cloud takes a bit of time every time. And here, this is exactly what I've shown you before. So this code has been deployed. And now I will configure Apache API 6 to intercept the call and to direct the /price stuff to this function. Done. And now, if I get back here, I can refresh. The result is exactly the same. If we check the logs, we can see that actually here I have a log about pricing computed from a monolith, and here I have nothing of the sort. So the pricing was actually not computed by the monolith, but by my function. And the good thing about this is that I actually didn't need to deploy a new version of my monolith. So the monolith can be released at any point in time in the future with out the chopped part, but for the moment it can stay as it is with no issue. And that's it. Thanks a lot for your attention. You can read my blog, you can follow me on Twitter. If you're interested to redo this demo at home, you can do it. The code is on GitHub. You need just to change the path and the authentication key for Azure so that you can actually use your own and not mine with my key. And if you're interested also about having another channel, I've written this talk in a blog post, and so please read it. Again, thanks a lot and have a good day.
Wow, this was really an exciting talk. Thanks to Nicholas for an exciting session. Now it's time to invite our second speaker, Nilanjan. Nilanjan Mana is a software engineer at Harness, where he developed a chaos engineering at scale. He is a core contributor to Litmus Chaos project, which is a CNCF incubating project. Today, he is here to talk about how you deploy a resilient Kubernetes app using Litmus Chaos. So the stage is yours, Nilanjan.
Hello everyone. My name is Nilanjan and welcome to this session on chaos engineering with Litmus Chaos, where we'll talk about the whys and hows of chaos engineering to understand its requirement and also take a look at how Litmus Chaos can simplify your chaos engineering requirements. Before we get into the talk, I would like to briefly introduce myself. I'm a software engineer at Harness, the primary sponsor of the Litmus Chaos framework, and priorly I have worked at Chaos Native, the founder of the Litmus Chaos project. In my day-to-day work, I'm responsible for assessing the resilience requirements for any given scenario and authoring chaos experiments that can suitably validate the resiliency of an application for different scenarios. From my experience, I can tell you that every chaos engineering practice is unique in itself, based on your application specific needs, and therefore it is crucial to emphasize on the right kind of experimentation with realistic hypotheses to simulate real-life failure scenarios that can affect your application. Before we kick off the session, let's take a look at the agenda that we'll be covering today. We'll start off by understanding the dependency of digital services in the present day and the challenges posed due to its scale of adoption. Then, we'll understand the cloud native dilemma and how IT service downtimes impact a company. Then, we'll take a look at what's chaos engineering and some of its best practices while introducing the Litmus Chaos. And finally, we'll see a demo of Litmus Chaos in action. So let's start by understanding the roots and origins of chaos engineering. Digital services are more relevant than ever before. There are a multitude of reasons attributing to this. However, the most significant reasons include rapid adoption of internet services by masses, which is becoming increasingly cheap and accessible, along with factors such as COVID-19 pandemic that force majority of the businesses to go online. On an average, we have 4.95 billion internet users today who spend about 7 hours per day to consume these digital services. To tackle the overwhelming scale of operations required for hosting these many users, mostly every business is choosing cloud computing to be the infrastructural backbone of these services. And that's how the term cloud native has come to be. The applications that run and scale at a cloud computing scale. Even legacy applications are choosing to be cloud native now. However, how can we determine their resiliency now that they are becoming cloud native? This question is relevant since cloud native applications are not that simple to operate. You have multitude of microservices communicating to each other, each serving its own purpose. However, it takes only one of these services to go out and take down the entire application. While the challenges of debugging such an application is another topic, the more relevant point over here is businesses should be able to ship their code reliably so that they're able to correctly assess their code in a cloud native environment. This is especially important because businesses now bring new features much faster and push much larger code bases more frequently. The culmination of all these issues is that, just to quote the Murphy's Law, anything that can go wrong will go wrong. In other words, the complexity of the development and operations will sooner or later cause failures. But the question is, how can we be prepared for these failures so that we can overcome them quickly? So let us understand the issues that we just talked about in a better way. Our applications, now being cloud native, stand atop a plethora of other services that determine its functioning and resiliency. You have your application dependencies, then other cloud native services provisioning the underlying infrastructure, then Kubernetes itself, and lastly, the platform on which your application is deployed. Failure in any one of these services can cause your entire application to not be able to cope up. This problem is only accentuated as more amount of code is now shipped more frequently at a weekly or even shorter cadence, which is expected to run in a multitude of different environments. So, this unpredictability of the application behavior is the prime cause for service outages, since there is no way to know how our applications will behave when subjugated to an unanticipated situation. Let's try to analyze the impact of service downtimes on businesses. According to a report by Logic Monitor, companies with frequent service outages and service brownouts, that is degraded SLOs, experience 16 times higher operation costs, need twice as many team members to resolve these issues, and take twice as much time to resolve the issues. While these figures indicate the level of threat that service downtimes and service brownouts pose, they don't cover the big picture. According to the 2021 Data Protection Survey by VM, the average downtime for an outage was 79 minutes, with the cost of downtime averaging at $84,650. According to ITIC in 2020, 1 in 4 enterprises indicated that a single hour of downtime can cost their firms from $1 to over $5 million, exclusive of any legal fees, fines, or penalties. The impact cannot be solely measured in cost per hour. There are many other potential downsides to outages as well. According to the respondents of the survey, there are 3 core impacts of the downtime. External impact, including loss of customer confidence and damage to the brand. Internal impacts such as employee morale and diversion of resources. And litigation and regulation, which can have a significant effect on company valuation. Therefore, the need of the hour is to mitigate, if not completely eliminate, the predicament of downtimes. What organizations need to acknowledge that it's not a question of if, but when will their organization will be affected due to one such downtime. While one can prepare for the apparent causes that need attention, no one can fully anticipate an overwhelming downtime before it actually takes place, as there are a plethora of ways in which things can go wrong. When the entire applications and their underlying infrastructures evolving at the pace of hours and minutes for the much needed competitive edge, how can we ensure that our distributed applications always withstand the chaos of adverse situations? By breaking them on purpose with chaos engineering. Chaos engineering is the way to go for all those enterprises who want to prioritize resiliency and reduce downtimes for their customers. It is about adopting a culture of building resilience against unforeseen challenges in their systems. So how does one make a system resilient against something unanticipated? By understanding the system behavior under turbulent situations which are representative of the real-world failure scenarios. These failure scenarios are created by virtue of the chaos experiments that we perform. The key to successfully practicing chaos engineering is to understand the complexity involved in your system through realistic experiments and hypothesis conditions. Only by fully understanding the pros and cons of your system will you be able to choose the right kind of measures for your system. However, we need to understand the difference between deliberately harming our systems and doing chaos engineering. We cannot stress our systems to the point that they break and phrase it as chaos engineering. Rather, we should create reasonable real-life circumstances that might affect an application's behavior and give us an opportunity to understand the application in a better light. So the question is, how to do chaos engineering efficiently? As far as the general best practices are, chaos engineering is a culture-oriented approach which finds its place as part of the DevOps practices, and hence, developers and SREs should work together for the best efforts. While developers should run chaos experiments from an early stage in the development pipeline and slowly scale their tests so that all different kinds of chaos scenarios are covered, SREs should focus on how to make the chaos engineering practices scalable to run them into CI/CD pipelines, as well as execute the said tests within the staging environment and eventually in the production environment. Also, it's paramount to have a robust set of chaos experiments that can cover all the different types of failures that might potentially affect the application. Lastly, you need good observability to assess the impact of the chaos throughout the system, and hence, your chaos engineering tool should provide with enough insights that can help you understand if the application is indeed deviating from its steady state in an unanticipated manner. These are only a few of the requirements of what a good chaos engineering practice looks like. So, how can you implement a great chaos engineering practice for your organization? Well, Litmus Chaos can help you do that. Litmus is a tool set to do cloud native chaos engineering. It helps both SREs and developers to automate the chaos experiments at different stages within the DevOps pipeline, like the development, during CI/CD, and in production. Fixing the weaknesses leads to increased resiliency of the system. Litmus adopts a Kubernetes native approach to define chaos intent in a declarative manner via custom resources. It uses the operator pattern and relies on the custom resource definitions to define the chaos experiments. On top of that, Litmus Chaos provides a UI called the Litmus Chaos Center dashboard, where one can orchestrate and visualize the results and metrics of the conducted chaos testing scenarios. It also features the Litmus API for programmatically injecting and managing the chaos, features for teaming and collaboration, GitOps management for chaos, and Chaos Hub as an open source marketplace for the experiments. It's also worth mentioning that Litmus Chaos has seen tremendous growth and adoption in major enterprises dealing in all kinds of technologies, further validating the need for chaos engineering and its versatile applications in all kinds of technical domains. There are more than 50 Litmus Chaos experiments that can be broadly categorized into two categories: Kubernetes experiments and non-Kubernetes experiments. Kubernetes experiments can further be divided into pod level, node level, and application specific experiments. Pod level experiments inject chaos on the application level by typically depriving the application of some dependent resource such as CPU, memory, network, I/O, etc. Some of the examples include pod delete, pod DNS error, etc. Node level chaos experiments target the underlying Kubernetes deployment infrastructure. They tend to have a higher blast radius and affect more than one application deployed on the Kubernetes cluster. Some of the examples include node CPU hog, node memory hog, etc. Application-specific experiments render a failure scenario pertaining to a given application deployed in a cloud-native environment, such as Cassandra pod delete experiment, Kafka broker pod failure, etc. Non-Kubernetes experiments typically target public cloud infrastructure resources such as AWS, Azure, GCP, on-premises, VMware infrastructure, and even bare metal servers. Non-Kubernetes chaos experiments are especially helpful for validating the entire application resiliency, even when your cloud-native services coexist with existing critical infrastructure services that are part of the traditional technology stack. Examples include EC2 terminate by ID, Azure disk loss, VMware VM power off, etc. It's also worth mentioning that Litmus Chaos experiments also support BYOC, bring your own chaos, which lets you integrate any third-party tooling to perform the fault injection, while the validation of the chaos parameters happens through Litmus Chaos. They can also be paired with Litmus probes to automate the process of validating the resource state before, during, and after the chaos interval. And with that, we are up for the demo, where we'll see Litmus Chaos in action as we perform an HTTP chaos experiment to assess a cloud-native application. See you on the other side. Hello everyone, and welcome to this demo on Litmus Chaos, where we'll see that how we can create our own chaos experiments and assess the resiliency of our cloud-native applications. Before we actually go ahead and create any of our own chaos experiments, I would like to show you the online boutique shop. The online boutique shop is a e-commerce application where you have these items which you can buy. All of these items are available and listed over here. We can go ahead and take a look at individual items, add them to the cart. You get the big picture. It's a e-commerce application. But what's different about this e-commerce application is that it's completely made out of Kubernetes microservices. You have your different parts of the website as individual microservices, namely the carts, the front end, so on and so forth. What's the objective of this demo is that we are going to perform the HTTP status code chaos experiment. More specifically, what we are going to do today as part of the demo and this experiment is that we're going to target one of the application microservices and force it to send an incorrect status code. So for example, we have this cart microservice and we'll be forcing the container running within the pod of this microservice to send an incorrect status code, not 200 for example, since 200 is the normal status code that we'll be expecting. And we'll see that how the application behavior is when it receives such a incorrect status code. We also have our Grafana dashboard before we actually go ahead and create the chaos to measure the impact of the chaos that we are performing. So what you're currently seeing here right now is the probe success percentage, the first being the black box exporter metric, probe success percentage, which indicates that the front end, that's what we are monitoring using the black box exporter, is running correctly right now. It's in a steady state. While the other application parts such as the cart QPS or the front end or the product or the checkout, every page is working correctly right now. Each one of those have a marginal access duration, that is latency, and the QPS is also quite low. So what we are going to do right now is, first of all, we'll see these microservices that I'm talking about within the Kubernetes. So these are all the microservices that we have, the deployments that we have here with us. First of all, you can see that the cart service over here, it's having only one replica. And in fact, all the microservices that we are having have only one replica only. So what do you think will happen when we are going to target this one replica that we have with this HTTP status code chaos experiment? Well, let's try to find out by creating this experiment. So I'll go back to my chaos center and try to schedule a new chaos experiment. I'll be using the self agent since my application, the boutique shop application, is also installed in the same cluster where the Litmus chaos has been installed. Next up, I'll be going to the Litmus chaos hub since we need the HTTP chaos experiment, which is present in the Litmus chaos hub. And I'll name this as HTTP status code chaos. We can then add a new experiment name and we can search and add this pod HTTP status code experiment. Next up, we'll be editing this experiment in order to specify the target application and other experiment metrics. First being the application namespace. So our application namespace is Litmus since I have installed this application in the same namespace as Litmus, while the Litmus is running in a namespace scoped installation. So both the application and Litmus components are installed in the same Litmus namespace. For the application kind, we'll be using deployment, and for the app label, we'll be using the cart service. That is the cart microservice that we want to target. We'll be going next. And now we'll be adding a probe. So what is a probe? A Litmus probe is a way for us to programmatically define the hypothesis check that we want to perform as part of our chaos. So how will we do that is I'll be defining a cart probe over here. The probe's name is cart probe, and it is a type of an HTTP probe since we are going to make HTTP requests as part of this probe validation. And we'll be doing so in a continuous fashion with an interval of, let's say, timeout of, let's say, 2-3 seconds, and then retry once upon failure at an interval of 1 second, while the probe polling should happen at an interval of 1 second. For next, we now need to provide a URL because we'll be performing our GET request or the validation that we want to make at this endpoint. So this is the URL of the application that we have copied from here, which we'll be providing. And what we are going to do today as part of this probe is basically we'll be performing some GET request while expecting a status code of 200. As the application stands right now, it's in a steady state, and therefore we have 200 status code coming in probably. We can validate that using this probe success percentage. It's at 100%, which indicates a normal application behavior and 200 status code. So the argument that we are presenting before ourselves is that the application behavior should remain the same. The status code should be maintained even when it is subjugated to a chaos. But will that happen? Well, let's see. I'll be going ahead and adding the probe. Then I'll be configuring the experiment parameters. So let's say that I want to perform the chaos for 60 seconds at an interval of 60 seconds so that we have only one iteration of the chaos. And for the status code, let's say that I want to send a 500 status code. For the target service port, we need to provide the target port of this container. So the container is running at a 7070 port, which we can get by seeing all the services that we have. So we can see that the card service, it is a type of cluster IP service, is running at a port of 7070. That is the container port. So we'll be providing the same port here. And finally, we need to provide the appropriate container runtime. So I'm using containerd, and hence I'll be providing the containerd runtime. Finally, the pods affected percentage, that is what percentage of the pods we should be targeting. So as we just saw, we have only one pod, but I'll still go ahead and put 100 here. You can go next and we can then basically finish, since we don't need these options. And with that, we have just completed specifying our chaos experiments, as easy as that. So yeah, let's actually go ahead to next. And I'll keep the weight as 10 for the experiment for the calculation of the resiliency score, since we have only one experiment. Again, go next and schedule the experiment now and then finish. So yeah, our experiment is right now created, and we can see that the experiment is running right now. So let us wait for the experiment to actually start once the installation of the chaos experiments is over. Alright, so as we can see over here, the experiment has just started. Let us go ahead and take a look at our application dashboard to see what we can see, if we are able to spot anything different or not. Here in the application dashboard, we can see that up until now, everything has been maintained in a steady state manner. However, just with the start of the experiment, we can see that slowly the access duration of our application is going up. Let us actually wait for some few more moments to see what happens. Okay, so immediately we can observe that right now the access duration or the latency of our application is sharply rising. It's in vicinity of somewhere around 2 minutes, just shy of being 2 minutes, which is a good amount of duration or latency. We can observe the same behavior for the front end as well. And simultaneously, we can also see that the QPS, the 99th percentile QPS, is going down while the mean QPS is going up. And if we actually try to refresh our application, we can see that our application doesn't refresh. The request is actually not able to go through. And we also got a debugging error over here, which says that, well, HTTP status 500 internal server error. So yeah, we are getting the 500 status code, which we actually forced upon the microservice, the card microservice, to come upon here. So what's happened has our application is not resilient. As we can see that we can already observe that our application is not behaving in the way that we want it to behave when we are subjugating it to a HTTP status code error. We can already ascertain that from our application dashboard over here, or from the front end of the application as well, that our application is not resilient. However, when we are performing this using in a CI/CD pipeline and not doing this or checking for these metrics manually, we should be able to have some kind of automation to basically being able to check all these metrics for the chaos in an automated fashion. So let us see whether the probes that we have defined has been actually able to capture this anomaly or not. Our experiment is already over, so let us actually go ahead and check the experiment logs. We can do so by checking the logs over here, and it contains all the different stages of our application execution. We can see the probe information over here just before starting of the experiment, and the chaos duration, as well as the pod that we have targeted over here. All the metrics are here, and after that we can see that somewhere around here the cart probe is actually failing because the status code that it is getting is 500 and not the expected value that we had defined is 200. So this deviation of the steady state of the application is the cause of the failure of this experiment. As you can see, the experiment step has failed and the overall verdict is failure. And we can see in the end as well, it says that the probe has failed and therefore the experiment has failed. We can see the chaos result to just get a crisp understanding of the same thing. It says that the phase of the experiment is complete, however the verdict is failed, the experiment has failed, and the probe success percentage is 0. So we had only one probe which failed, therefore the probe success percentage is 0, and the probe that has been failed is the cart probe. And we have a short history of our experiment runs over here as well. The failed runs is 1, since we have already one experiment run so far. So with this experiment run, we observe that how we can basically create our own litmus chaos experiments and target them against our own Kubernetes applications in order to assess their resiliency. Now you must be wondering that how we can basically make this application more resilient. Well, based on the data that we got, one pod is not making enough inroads basically to handle such kind of a chaos where we are giving it 500 status code. So we can additionally add 2 pods. Basically we can create some kind of duplication here so that our requests go through. Alternatively, we can also mend our application code in order to make sure that this kind of condition is handled where we are getting false status codes. So yeah, that's about the mitigation of the chaos from the results that we obtain, and those steps can basically help us to get a past experiment. But yeah, I'll leave that to you guys to experiment. That's it for this demo. Thank you so much.
Okay, so I hope our audience enjoying the session. In case you have any queries, feel free to ask in the YouTube chat windows. So it's time to move to our third speaker, Chris Smith. He is a developer, trainer, and consultant to many US and UK government departments. Today, he is here to talk about policy as a version code. Here you go, Chris.
Hello. Well, okay, so elephant in the room, policy is a dull thing. It's kind of hard to make it sexy, but I'm going to try and get your attention, so bear with me. So, to set the scene, I'm in a lift. Yes, American friends, we really do call them lifts. 4 people walk in. I think to myself, Chris, this is your moment, now or never. As the doors close, I position myself in front of them. A captive audience. They're mine. I've got them. I hear the door seal shut behind me, and I take a breath. I look to the first person on my left. She's in a suit. She looks really important. I gesture to her. See? She looks back at me as if to say, yes, go on. She nods. Perfect, the CIO, the policymaker, the one whose neck is on the block. What are the chances of finding you in my imaginary lift today? I ask her, well, what keeps you up at night? And she tells me, I don't know what teams are really doing, the volume of risk, and what I should then show more interest in. Setting and changing policy is hard, and to communicate, and people just go off and do their own thing. They think they know better, and to be honest, often they do, but I'm ultimately left playing catch up with the risk that they've signed me up to. Okay, I say, try not to sound like a patronising snake oil salesman. I can help. I turn my attention to the second person, also in a suit, but they look slightly less important. I make a guess. Let's face it, this is my imagination. It'd be weird if I was wrong. Product manager, I say. They nod. The whip cracker, I say. Well, what's important to you? So managing risk, mostly opportunity risk, the fear of missing out. So getting features out the door, avoiding getting bogged down with, they glance to the CIO, bureaucracy that feels almost like it's designed to slow me down. Awesome, I say. This is your lucky day. I turn to the next person, dressed in overalls. I'm in a trendy part of town. They could be the CTO. Before I asked, they sense me staring at them. Cleaner, they say. Well, how did you get in my imagination? Okay, let me come back to you. My attention goes to the last person, hoodie, headphones around the neck. My stereotypical developer. Yes, I know you well. What code do you write? I ask. It doesn't actually matter. Python. Cool. Have you got everything updated to work with? I pause. Python 3? They volunteer. Yes, Python 3. That must be hard, I add. They don't know it, but I've actually just won a bit of their trust, which is, as we know, important. Nearly, they say. Cool. Okay, well, what's important to you? Staying on top of patching dependencies so that we can react to the next fire, knowing what rules exist, what ones I can bend, break, and what might cause me to lose my job. Writing consistent, good quality code and avoiding technical debt, so the rest of my team being able to work cohesively as one. Do you use any tools to help you with that, I ask? Yeah, linters, code quality, test coverage tools, the usual. Great, I say, I write code too. Let's be friends, and I hand them a printed QR code and say, here's my public GPG key, so you know that you can trust what I say. I return my focus to the cleaner. I've got it. How do you get told what to do and when it changes? Well, we get a memo, or something gets stuck to the notice board. So last week we got a memo saying that all the meeting room whiteboards needed to be cleaned every night. Interesting, I say. How does that work out? Well, it's up to us to then maintain the to-do list so that we can onboard new people. Does it go wrong at all? Yeah, sometimes when we compile our operational manual, we miss a memo or don't apply them maybe in sequence, and we do get things wrong. They glance apologetically to the project manager. Like when we hadn't updated the guide that the meeting room on the 3rd floor was being used as a dedicated war room, and we wiped all their boards down. I look to the devs. Does that sound familiar? I ask. They nod. Turns out we're not all special snowflakes, hey? All is not lost. I knew there was a reason that I imagined you here today. The lift is slowing. I feel it coming to its destination. Great, I've got the silver bullet. The CIO looks to me, ready to buy whatever it is I'm selling. They ask me as the doors open, who are you and what team are you in? As I move out of the way so to stop obstructing them, I answer, I didn't work here. I just here to fix the lift. People have been complaining that it only goes to the top floor no matter what button they push, and it's actually pretty slow. My audience storms out, furious, heading towards the stairs. The door's shut, and I get back to my job. Okay, so if any of this sounds familiar and you can relate to my imaginary friends, then I've got the answers for you. What if I said you could update policy easily, even releasing, say, several version updates, not just in a year, a month, what about 10 updates in a single day, and seamlessly communicating that to the people that need to consume it, all without derailing them? You could have visibility on compliance tools, maybe that you already use, and that policy that could be readily consumable, easy to pass, demonstrate compliance, and make sense and not be bureaucratic to change when it needs to be, and ultimately not get in the way. That same policy could be treated as a dependency and operate like a linter, so you can run compliance checks locally in CI and guard production ultimately. That multiple versions of the policy can act like a dependency and are supported, so emergencies like you must update now because there's now known vulnerability type updates are in effect a business as usual activity to communicate. Interesting? Okay, hang around. Let's crack on. Now, I've hopefully got your attention. It's time to introduce myself and start explaining things. My name is Chris Nesbitt-Smith. I'm currently an instructor for LearnKit and also Control Plane, a consultant to the Crown Prosecution Service in the UK government, and a tinkerer of open source things. I've spent a fair amount of my professional career now working in UK Gov and large organisations where problems like these are rife. We'll have time at the end for questions and heckles, so please kind of leave questions in the comments. So, while this is not live or in person, where I might be able to ask you to, say, raise your hands, we can still try some audience participation. So, if you could leave a comment of policymaker, if you're with my CIO and have set, written, or applied policy before. I'll give you a few seconds to do that. Just if you've written policy, just leave a comment of policymaker. Okay, next round. If you have ever sought exemption or maybe consciously bent, broken, circumvented, ignored, bypassed, whatever, a policy with at least good intentions, could you leave a comment of policy breaker? So if you've bent, broken, circumvented, ignored, bypassed the policy, hopefully with some good intentions or not, leave a comment of policy breaker. Well, hopefully some of you at least fell for it. So we've got all of your names and employers' details, so kind of lend me your ears, the stakes just got raised. So where do I see policy as code going wrong? Well, before we dig into that, what do I mean by policy? So it usually comes in one of two forms. So security enforcing, like data at rest being encrypted, for example. Or maybe perhaps consistency enforcing, such as code style tabs being 2 or 4 space indentation, maybe. Or maybe you can think of some others, but in any case, it's hopefully intended to mitigate a risk of some sort. However, with the best of intentions, there are often emotionally led rather than being grounded in proportionate control, which is ultimately the open door to a case-by-case exemptions then being required when you come against a situation that you weren't anticipating. So this is not fundamentally unlike how the laws of the land are created, with case law making for a complex to navigate rulebook and harder still to measure for compliance. It often looks like the thin end of a wedge where the precedent, which may have been an uncomfortable pill to swallow the first time round, becomes dangerous, with others ultimately looking to expand upon its scope. Which can lead us to wonder sometimes if the cure was actually worse than the disease. But that's not how we, at least typically, develop software. So why does this have to be so hard? There surely must be a better answer. Well, we've codified everything else, so isn't that the answer? Well, yes, in part, but my point of this talk is that we do it wrong. Maybe some of you are screaming your favourite product name at me in your heads as the solution, and you're not wholly wrong. But the devil's in the detail. Just throwing some curly braces at something doesn't inherently fix things, though. So if it's a security control, it's often tempting to keep the policy a secret. Exposing it could maybe be used against you by an adversary. However, that does not support us shifting left at all. It results in devs effectively reverse engineering what the policy is by finding out when we smash our heads up against it. It doesn't therefore take much imagination to see that in the scenario of an application deploying midway through, finding one resource is non-compliant and rejected would have the overall deploy in an inconsistent halfway state, likely resulting in downtime. Which begs the question, was the policy better than the downtime and the impact? Especially if it leads your engineers, who are all hopefully all plenty smart, at finding inventive, shall we say, ways around the computer says no response that they've got. This is further exasperated when updates to the policy are desired. So maybe you get a pen test or something goes wrong, so you form that case law in effect that you maybe need to apply a new policy. So, for example, maybe all S3 buckets now need to be encrypted, a change that could be considered a breaking one. Sure, you might say, we provide warnings on at least the less important issues or new emerging policy, which is great, so long as someone sees them. But if you've adopted GitOps or at least CI/CD, is anyone seeing those warnings? Who studies the results of a successful build log every time? Anyone? Every time? Well, if you are, I politely suggest you're probably missing the point of CI/CD. You should ultimately be able to trust your job status. Okay, well, I'm not just here to throw stones. So remember my implied promises to my 4 imaginary friends of what that future promised land might look like. Well, there's nothing new under the sun here. We've actually already unwittingly solved these problems elsewhere. We just need to remind ourselves and join the dots together. Well, the first is something if you're doing policy as code, you're probably already doing by putting it in version control. The thing you might not be doing, though, is making that then visible. So, at least inner source this, by which I mean allow everyone within your walled garden of employees, suppliers, subcontractors, so on, to see the policy. I'm not saying you give all your threat monitoring rules and intel away. You can probably keep that to yourself, but I'd argue visible policy and the gaps therein is often better than the downtime, reversed engineers workarounds, and opaque legacy exemption spaghetti soup. So, if you're brave, you might even open source it. You'll find it unlocks the ability to work well with prospective suppliers without NDAs and whatnot. And ultimately, widely distributed secrets are expensive to maintain, difficult to handle, and often only stay secret for so long after all. Okay, well, we're off to a good start. Our policy is visible now to those that need to see it. So, many of you no doubt are used to semantic versioning, but a quick recap. The first segment is used to indicate a breaking, perhaps conflicting change. So in the context of policy, let's say it's requiring resources to have, say, a department label. Maybe that will help with some internal cross-charging. Who knows? I'm not judging. An increment to that might look like requiring that to be a predetermined list rather than just free text. The next segment is to indicate minor changes that shouldn't really break anyone. So an increment to that might look like correcting a spelling mistake on one of the department names. The third segment is to indicate patch changes. So these should be a no-brainer to keep up to date with. So an increment to that might look like adding a department to the available options. Okay, so our policy is visible in a repository now. It's versioned so we can easily communicate the policy. We can tack on release notes, and expectations are managed by our semantic versioning. In software, we're used to handling dependencies. So what if your policy was just another dependency? So you might unwittingly already be doing this, for example, if you use, say, ESLint as a dependency in your JavaScript package. So our policy is visible in a repository, it's versioned so that we can easily communicate the policy, and we can tack on release notes. And expectations are all managed by Semver. It's beginning to look a bit more like software. Okay, so I know testing is a dirty word, but in order to make this an asset that everyone can depend on and also provide good examples, tests are essential to give everyone the confidence and the stability and surface potential side effects before they ultimately hurt everyone involved. Consumers of this policy need to be able to test themselves against the policy locally and in CI/CD, thus shortening the feedback and better informing things. So as a bonus, we should be able to find our consumers able to rely on the artifact that we're sharing with them. Well, we're well and truly on the home stretch. It's a dependency, so updating it should be no different to any other. We can even use some magic, like, say, GitHub's Dependable or Men's, now White Source's Renovate, to do that for us. So think automatic pull requests, tests, even auto-merging if you like. Okay, so to check you're all still with me, can anyone leave a comment below and tell me a recent event that caused everyone to want to know what version of a potentially logging doohickey we were potentially running everywhere in the estate? Yep, as you know, all presentations this year are contractually required to reference log4j, even if it's almost entirely out of context, and include some memes. In just a few short months, I'll be able to remove these and hopefully just point broadly at a set of scary looking CVEs in order to continue commanding your behaviour through fear. What I'm getting at here, though, is that situational awareness piece around software supply chain is something the organisation is hopefully already thinking about, if not perhaps addressing. So if our policy is a dependency, this is at least not a new problem. Software bill of materials for the win, right? Which then can allow us to measure the compliance across the estate. So I've just covered a lot of ground and hopefully sounded convincing, or at least a little bit. And it's not just a fictional utopia that's painted in PowerPoint. It's time to look at how you might be actually able to do this. And I know you really came here wanting to be able to see just a million words on a slide, not just the odd emoji or two that you've seen so far. So we've reached the point of the show where I get to show you some code. Hooray! So to maintain scope, I'm going to limit things to talking about two things to prove that it's not just one tech or one tool. I've arbitrarily picked Terraform and Kubernetes, but I could have probably picked anything. Naturally, I'm going to need some tools to do this. I'm too lazy to really invent anything here myself. So likewise, I'm going to pick two tools. But again, I could choose any or even all of them, probably. So Chetkov is going to be doing my Terraform and Canervo will be doing my Kubernetes. So if you want to kind of browse along with me, I've created an example GitHub organization here. So I'm not expecting you to kind of read or grok the code off the video. So don't worry about it too much. I'm showing it here just to prove that this is a real thing. But github.com/policy-as-version-code. So let's kick off. So the policy is stored here in the policy repository. So here's where my policy starts at version 1.00. I've got policy that requires a department label on all resources. In effect, so long as it's set, doesn't matter what it is, but it needs to be defined. I've written tests for this, so note how the parsing test cases are usable as a great example of what good and bad looks like. We pushed a tag in Git, we've added release notes, and I can sign it to provide further assurance if my heart so desires. It does, obviously, but moving on. Version 2.00 looks similar, only now that the department field has to be one from a predetermined list. Like before, test exists, release notes are written, tags are signed. 2.1.0 is where we notice and correct a spelling mistake of one of the options in that list of departments. 2.11, and I've now added a new department to the list. Okay, so there's some other repositories that are in that org. App1 and Infra1, well, they depend on version 1.00 of the policy. It's not compliant with version 2 or greater. But how do I know that? Well, I've configured Renovate to automatically make me a pull request. So when there's a new version of the policy, it's super obvious if I can update my dependency and I can see clear feedback about where and why I'm not compliant. I can also see all the pull requests over the organisation, so I can measure the compliancy of my policy as a whole. Moving on from that, App2 and Infra2 depend on version 2.00 of the policy. However, we could actually merge that open pull request all the way up to 2.1.1. Finally, App3 and Infra3 are dependent on 2.1.1, and they get a gold star from the CIO. There is, I'll admit, a small touch of magic, and it's not pretty right now. I've written some bash. Don't judge me, even though I probably definitely written worse though. So what this does is it allows me from my dev laptop or in CI to evaluate my code against the version of the policy that's defined in the resources. Ideally, this might be less cumbersome, but it is what it is for now. Pull requests and collaboration on this are very welcome. And the last piece of the puzzle is managing the life cycle of the policies and allowing multiple policies to be accepted and evaluated within a single runtime. I've cheated a bit here. Kubernetes gives you admission controllers. It's not so easy to get the same policy evaluation I've found so far in cloud. Ultimately, the cloud vendors have got their own policy code, and I've not figured out how to be able to evaluate that policy locally. Again, pull requests, contribution, collaboration from the community are all very welcome and really appreciated. So you may have noticed that the way the policy is designed and distributes itself lends well to coexist in a Kubernetes cluster. Which brings us to cluster 1, which describes a cluster that accepts all the versions that we've described so far. Likewise, cluster 2 only accepts version 2.00 and greater. We can automate this with Kind for CI to deploy the applications too. And there we have it, a full org, all done, all compliant, policy, all versions, CIO, all aware of what's going on. So this is great, right? But just one more thing. Wouldn't it be awesome if the policy maybe carried a story, a narrative of why it exists in the first place? After all, if your agile team is even half effective, it will reject anything that it perceives as friction if it doesn't see the value in it. It could potentially allow our developers and engineers to know why they're compliant, and if they want to do something outside of what the policy permits, they don't need any sort of exemption granted per se. They can have then a well-reasoned and informed debate with rationale behind a pull request to the policy. So imagine, if you will, this going through the stage of versions with risks that inform the mitigations manifested as policy, all maintained as one. So when the risk landscape changes, your policies can then move with it. So when some new privacy regulation comes out, or your latest marketing strategy pays off and you acquire more data, for example, even if your policy was perfect at one time, the risks and the appetite for that stand still for no one. So we can liken this to perhaps over-provisioning that we might be familiar with from elsewhere, where lead times are long, change is hard, and there is a significant pressure in just nailing it the first time, which can lead us to hedging our bets against what some future state might look like, rather than proportionate mitigation to the risks that are more tangibly real in the now. And that's where the real culture change is needed, and the execution of that is likely a long series of talks in of itself. So this is now really over to you. Honestly, the best thing you could do right now is tell me this is madness. Already done, irrelevant, otherwise unachievable. Something so far my esteemed echo chamber of peers have yet to do. So, beyond making pull requests and developing the theory more, I'd really like to start building a case study with a willing organisation and allow me to swap out my imaginary friends for some real ones. But the most important thing I want you to remember from our time together is that, and feel free to say this out loud with me, purposeless policy is potentially practically pointless policy. And I've been practicing saying that far too many times. So I've been Chris Nesbitt-Smith. Thanks so much for your time. You're now free to drop off if you wish. I'm assure you I will try and destroy the evidence of your guilt admissions earlier. I'll try. Like, subscribe, whatever the kids do these days on LinkedIn, GitHub, whatever. You can be assured that there'll be near on no spam because I'm, or much content really at all, since I'm pretty bad and awful at self-promotion on social media. cns.me ultimately just points to my LinkedIn. Talks.cns.me contains this and other talks, and they're all open source as well on GitHub. Questions are very welcome on this or anything else. I'll be hanging around in the comments section, or ping me a message, probably on LinkedIn, and I'll come back to you. And thanks so much for joining me.
solve actually. Productivity. Let us understand a simple software release cycle. So in order to develop any
Okay, so next we have Megha Kadur. She is working as a senior software engineer at CGI. She is a frequent YouTuber and blogger, and today she is here to talk about her DevOps journey. Over to you, Megha.
Hi everyone, my name is Megha Kadur and it's a pleasure to be presenting at Open Source Community Conference 2022. So today my talk is all about my journey into DevOps world. How did I become a DevOps engineer with no prior experience in IT field? So before starting the presentation, let me give you an overview about the things that I will be talking today. So I start with my background and then I'll talk about how I got introduced to DevOps. Then what is DevOps and what challenges DevOps is trying to solve actually. And then I'll talk about the few things that you should know before starting your DevOps career. Because I started as a non-IT background and there were many things that I was unaware about. So in my DevOps journey, I started learning those things. So then I thought, okay, if I would have known beforehand, would have actually helped me in fast tracking my DevOps career. So that's all, and so let's begin the presentation. Talking about my background, I have done ECE Electronics and Communication Engineering and I have worked for almost 3 years in this domain. I started off as a testing engineer where I was testing the specification of the products and components. Later on, I wasn't happy with the job role that I was performing, so I started exploring different career options. So that's when I got to know about DevOps. And then I wanted to know how it works and what are the things. So I started searching in Google like what is DevOps, how it works, what are the skills required for that, and many more. There was plenty of information available about DevOps regarding its life cycle and its tools. Information like what tools can be used like Docker, Jenkins, Kubernetes, various other cloud providers like AWS, Azure, GCP, and many more. So it was a lot of information for me to grasp at that time. So I took one step back to understand what DevOps is and why are we implementing DevOps culture and what are the challenges that DevOps is trying to solve. So let's try to understand what DevOps is actually. DevOps in simple term is an integration of development and operation team. It tries to improve the collaboration and productivity. Let us understand a simple software release cycle. So in order to develop any application, it starts with the idea, gathering the information. Later on we plan the features that needs to be included in the application. Then the developer writes the code. Testing of the code is done. Then we package the application so that it can be deployed in the production environment. And finally, we monitor the application. So that's what a simple software release cycle looks like. So while developing the application, we might face challenges and problems such as managing and tracking the changes in the code is difficult. Manually testing of various components or modules of the project takes a lot of time. Incremental builds are difficult to manage, test, and deploy. Ensuring consistency, adaptability, and scalability across the environment becomes difficult. Also, due to lack of collaboration and miscommunication between various teams that are working in a project, there is an uncertainty that whether the code will work perfectly fine in the production environment or not. We may also encounter issues such as blame game, where the dev team tells that the code is working perfectly fine in their system, whereas the operation team on the other hand tells that the environment is configured perfectly fine. There must be some issue in your code. So this is a kind of blame game that goes on. We may encounter unpredictable issues in the production environment that had to be fixed at an early stage. There will be release and deploy mismatch happening, and there will be lack of monitoring and feedback. There comes DevOps, which is one solution for all problems. DevOps is not a particular team nor a person, it's the state of mind. And we work in collaboration to solve the issues and deliver the product on time. It's a culture and implementation of best practices with the help of DevOps tools. So I took an online course to understand how we can implement the DevOps. And then in my DevOps journey, I started using many DevOps tools. But I had to still figure out why am I using these tools. Then I started to understand the concepts like version control, what is CI/CD pipeline concept, what is infrastructure as code concept, and started relating these tools with the concept. What is version control? Version control allows you to take snapshot of your project. It allows multiple users to manage multiple revision of the same unit of information. Git is one of the famous version control tool, and we have github.com as the code hosting platform for collaboration and version control. Git records the changes that are made to the file. So I started familiarizing myself with these various Git commands, and this is one of the tool that you will require your entire DevOps journey. So do learn Git. Topmost demanding cloud platform are AWS, GCP, and Azure. We can start learning with any one of this cloud platform. I started my cloud journey with Azure. So all of these cloud providers have similar concept. It's just that the naming and interfaces are a little bit different. Next concept is DevOps automation with infrastructure as code. Infrastructure as code provides us a way to define our resources in a declarative manner and put them together in a single unit called as configuration file. Most of the cloud providers have their own infrastructure automation, like AWS is having CloudFormation, GCP is having Google Deployment Manager, and similarly Azure is having Azure Resource Manager. So let's move on to some benefits. Speed. It allows us to set up a complete infrastructure by just running the scripts, and we can do it for any environment like dev to prod to QA. The next benefit is low cost. It helps in lowering the cost of infrastructure management. We won't have to spend money on hardware or even rent any physical spaces to store them. The next is increase efficiency. You can deploy your infrastructure architecture in many stages, which makes the whole software development cycle efficient, raising and increase the team productivity. So the next benefit is consistency. Manual process results in mistakes. So these tool helps us in solving these issues by allowing us to write the configuration files that can be deployed again and again without any discrepancy. Let's move on to next concept, that is containers. Containers are packages of software with all its dependencies and libraries together to run in any environment. Docker is the famous containerization tool. It helps us to build the code at developer side and finally ship the code and run it in any environment. No matter it is dev, QA or prod environment, it will for sure run seamlessly. Let's move on to next concept, that is container orchestration. Kubernetes is popularly known as container orchestration tool. It manages the availability, scaling and networking of containers, monitoring the clusters and managing the timing of the container creation. Consider this rectangular space as Kubernetes cluster. So what is a Kubernetes cluster? Clusters are considered to be a set of nodes that run containerized application, and each cluster will have at least one worker node. So what are nodes? Nodes are machine. They can be physical, on-prem or virtual. A node can have multiple pods running in it. So what are pods? Pods are the smallest unit of Kubernetes. We can run single container or multiple containers inside a pod, and each worker node will have multiple pods running. And if a container stops or dies inside a pod, it will automatically get restarted. So let's move on to one other concept, that is configuration management. Once we have our infrastructure provisioned, the next step is to make sure that everything is configured. So we can use various configuration tools such as Ansible, Chef, Puppet, SourceStack and many more. Now we have CI/CD concept. CI/CD is the backbone of DevOps. Continuous integration and deployment is a series of steps that must be performed in order to deliver a new version of software. It helps in improving the developer efficiency, faster software build, easy to find bugs, and improve collaboration. There are plenty of CI/CD tools available, such as Jenkins, Circle CI, Drone, Azure Pipelines, GitHub Actions, and many more. So I started my DevOps journey from Jenkins, and then I started using Azure Build and Release Pipelines, and many more. Nowadays, IT companies are adapting more of proper data analytics and log management. So Grafana, Prometheus, ELK Stack, Splunk, all these are examples of monitoring and log management. Let me share few things I wish I knew before starting my DevOps career. Since I'm coming from a non-IT background, there were many things that I was unaware about. So then I thought that if I would have known beforehand, it would have actually helped me in fast tracking my career. So the first thing is learning a programming language. So I'll share one of my scenario like where I faced challenges. So I was assigned to a project and I was creating this build and release pipeline. So at that time what happened is the pipeline used to fail with different kinds of error, and since I was not much aware about the programming language, it was difficult for me to distinguish between the error. Is it because of the code issue or is it because of the configuration of the pipeline that I have done? So in this way, programming language will actually help you. If I would have known those programming languages beforehand, it would have actually helped me in like identifying those issues. So I prefer that in your DevOps journey, learning a programming language is actually a benefit and a plus point for us. So the other thing is understanding the concepts. So usually when people say that we want to change our career to DevOps or some other career, we just think about the first thing that comes into our mind is like what are the tools that we need to learn in order to get the job. But that's important, but that's not the first thing. The first thing is that we need to understand the concept so that we can relate those tools with the concept and try to implement the DevOps culture in our project. So I also had the same kind of issues. So then I started learning what DevOps is and how it actually solves the problem, how it is solving the problems, and what are the roles and responsibilities. So that's how I started learning DevOps, and I continue to work in DevOps domain. The other thing is learn any scripting language. So this will actually help you in automating different tasks. So when I was creating different build pipelines and release pipeline, there were few steps where we had to write the script and automate it. And at that time, as I said, I wasn't aware about this scripting, and since I'm coming from a non-IT background, so I had to learn those scripting language and then create the script and add it in the pipeline. So scripting language is a kind of benefit. If you know it, it will help you to automate your task. So the other thing is communication and collaboration. So we feel communication and collaboration is not important, but as much as learning DevOps tool is important, communication and collaboration is equally important, because if we have technical knowledge and if we are not able to convey that, then it's very difficult to survive in this DevOps world. So initially when I started my DevOps journey, I was facing issues with communication also. So then slowly I started to communicate with people, collaborate with people, trying to understand the different technologies and concepts. So it's a kind of like collaboration, and we were able to solve the issues. So that's what communication and collaboration is equally important. Thank you for joining my session, and I hope it's beneficial for you all. You can connect with me on LinkedIn, Twitter, or on my YouTube channel. Thank you. Have a nice day.
Okay, so hope you are having a great time here. We have our next speaker, Rodolphe Felishek. He is an IT solution architect at 7bulls.com, and today he is here to talk about Canary sandbox environment to the rescue of AIC testing. So let us welcome our next speaker.
Okay, welcome everyone to my little talk about the Piacere project, especially focusing on the Canary Sandbox environment tooling part of that project. My name is Radosław Pilisek and I will be your speaker today. I'm an IT solutions architect at 7bulls.com, and this project that I'm presenting, the Piacere project, has been funded by the European Union via the Horizon 2020 program. A little bit about my company, so 7bulls.com. We act here as a research and development center. We have such status in both France and Poland. We are a Polish company. If you are interested about what we do with respect to the research and development, the details and the different projects that we are involved in are on 7bulls.com/R&D. And the agenda for today's talk. So we start with an introduction to the DevSecOps. So what does that mean, DevSecOps? This actually appears in the abstract of this talk, but not in the title. Piacere intro. So Piacere as a project, what does it do? What's the relation between Piacere and the DevSecOps, and what does it contain actually? And finally, the goal of today's talk is to describe Canary Sandbox environment in some more detail. So starting with the intro to DevSecOps. So as with any term in the computer science, in informatics in general, we can find some formal definition for that. Especially in terms of those more technical IT definitions, Gartner is a good source to look at. And no surprise, we've got a definition what DevSecOps is. So by Gartner, DevSecOps is the integration of security into emerging agile IT and DevOps development as seamlessly and as transparently as possible, etc., etc. So as you can see, this is quite a large definition, but in my opinion, it can be simplified greatly. So my take on that is this. So DevSecOps is about not forgetting about the security when doing DevOps. And this is done ideally without slowing oneself down. So without losing the flexibility, the agility that we normally gain via DevOps, via switching to the DevOps approach, yet not forgetting about security in that. And how to do that we'll see soon. This is why we are introducing Piacere, why this project was created. And this is actually an acronym, but as is the case with the European projects, the acronyms are quite funky. And in this case, you can see which letters were used in that acronym. But basically, piacere has been chosen as a word because it's an Italian word for pleasure. So it's an actual Italian word. And the acronym's definition is programming trustworthy infrastructure as code, so IAC, in a secure framework. So Piacere as a project basically delivers this framework that is supposed to be secure in itself and able to deliver this secure framework for your infrastructure as code. So basically, this is secure inside and out, and it's related to infrastructure as code. So DevOps definitely, and this term about trustworthiness that has been happening in the various publications is also used in this expanded name. So as I mentioned, this is Horizon 2020 project in software development call. Our consortium consists of 12 organizations ranging from academia, business, and government. So we are actually here counted as a business, as a small R&D. And the project itself is led by Tecnalia from Spain. The schedule, as you can see, we are at the moment I'm recording this is about half into the project. When you watch it, it's a little bit past half of the project, but it's fine nonetheless. Probably it should be up to date enough for this presentation to still be worthy. And we as 7bulls.com, we are responsible for integration and the Canary Sandbox environment that is presented today in this talk. So little summary of the Piacere uses. So that's the framework, yes, but what does it do? What is it supposed to do? So it's all about the DevOps. So develop, build, and deploy applications because that's the final goal to get those applications rolling on some infrastructure. What we are focusing is the cloud approach. So managing cloud, hybrid, and multi-cloud approaches to this and maintaining configuring the infrastructure obviously to get this infrastructure under our applications and more specifically Piacere tries to optimize the usage of resources, allow to test deployments infrastructure, helps you actually avoid snowflakes and related conflict drifts because that's what usually kills the security in the infrastructure side. And if you don't know what a snowflake is, this is actually when you choose to avoid the regular flow and decide that you would like to configure some server by hand, for example. And then you end up with some configuration that nobody knows about except for its author. And this way you easily create this security hole for yourself and security issues. And finally, to keep it all churning happily. So this is end-to-end solution for getting it done and for ensuring that it still works afterwards. And a quick look at the architecture to actually pinpoint where the Canary Sandbox environment tooling lives and what the project is about still. So we have two parts, the design time and the runtime. In the design time, we have things like the IDE, which is based on Eclipse. It is able to call out to the DOML model checker, and the DOML is an acronym for the DevOps modeling language. So this project is also introducing a dedicated language for modeling the infrastructure. By the way, all these details are already available on project's website, so you can, on the last slide, to get the URL to that, the address of that. So for the details, you can go there. And me continuing now, we have the infrastructure code generator, which is able to take the DOML and convert it to, for example, Ansible and Terraform to have something runnable. Then we have IX Scan Runner, which does the security scan and validity scans that can be done statically. And its dynamic counterpart is actually the Canary Sandbox environment tooling. So for achieving the dynamic aspect of the testing, as mentioned in the abstract as well. Apart from that, we have the Git tooling, which is the central point where all the information is stored, the models, the final IAC is stored. Then the Piacere runtime controller, which navigates the runtime part of the Piacere framework. We have the infrastructure advisor, which does the monitoring, etc. The execution manager, which actually executes the created IAC, the IAC optimization platform, and the infrastructure elements catalog, all working in tandem to deliver Piacere's values. And now going into the Canary Sandbox environment, so maybe one click behind. As you can see, the Canary Sandbox environment tooling is not really connected with anything else except it being available from the IDE. So from the IDE, you get the user interface to deal with the Canary Sandbox environment tooling. But basically, you can imagine that whatever happens with that tooling will be usable by this IAC execution manager finally. So this creation that gets done there will be usable in this other part at the runtime. And going into the details on the Canary Sandbox environment tooling, what we are aiming to achieve is to allow this dynamic testing. So we know static testing is great. We should be doing static testing, but for some things, we still cannot say at the static testing level, where it's working the way we imagine it's working. Maybe because of the assumptions that are wrong actually, and the code executes differently. The infrastructure as a code executes differently than we imagined. Maybe because of how it's done, maybe because of the tooling that we actually use to run it. And this is our approach to let us test this in this sandboxed, isolated environment, let's say. And to achieve that, we have two solutions. So first one is the provisioner. So in certain cases, it's okay, you have the infrastructure, you would like to use it, but the target environment is actually cloud. Whatever you model using the IAC, you model clouds, you model it in terms of virtual machine instances, in terms of storage buckets, in terms of volumes, in terms of networks, security ports, etc., etc. And then the reality that whatever you have locally is actually not a cloud, or maybe a cloud that is dedicated to something else that was created by some department, etc., etc. And you cannot really use it. So you have to build your own solutions. And then you have this steep learning curve when you try to deploy solutions like OpenStack or Kubernetes. And this provisioner is making it simpler. So showing a simple way to do that in an opinionated way, obviously, because we have to cripple it down, let's say, to make it simpler so that it's easier to understand, yet it's usable in the context of this dynamic testing that we are going to do in this environment. And the other solution is to go mock-lord, so with mock APIs when we don't even try to deploy anything. Okay, and as the slide says, this is to test dynamic aspects such as this relevance, reliability, and security tests. that will be possible in such a case. Obviously, there is a trade-off, because if you go with the provisioner, you obviously use something else other than the target environment, like the AWS, for example. And in the case of Moclord, it's maybe, you could say, even worse, because you don't get anything physical in there. Well, not even virtual. You don't get any resources, in fact. So that's the two approaches, and a little bit on the details of those. So for the provisioner, as I mentioned, this hides this complexity and implementation details of those various solutions for the deployment. So whatever you do, OpenStack, Kubernetes, it's practically the same from this point of view. It's giving you back the credentials. You give it a list of targets, the servers that you can use for this deployment, and you get back the credentials to use that. So as I said, it's opinionated, and we are reusing open source technology. So obviously OpenStack itself and Kubernetes are itself open source, but also the deployment projects we are contributing back, for example, this OpenStack Collab project that we're using. And the OpenStack Collab project uses containers and Ansible, so Docker or Pullman containers to deploy the OpenStack components and associated helper components at the target machines. In the future, as was already mentioned, also Kubernetes deployment will be available. This is what we are planning to do with KubeSpray. And regarding the Moclord, because the time is running out, it focuses on the zero-cost infrastructure provisioning. So nothing is created. There are zero resources, actually. It only says that, well, you asked me for an instance, so I have this instance. If you ask me again, if I have this instance, I have this instance, but there is nothing you can use, in fact. So this is entirely mocked and entirely faked, I would say even. The current focus is on the AWS, because that's what the use cases want. Use cases are actually hybrid local AWS, so that's the reason. And in the future, maybe something else will be considered, but it's not the case at the very moment. And what we are doing, we are also extending the open source libraries, in this case, open source Moto library, to provide the features that are required by our use cases, especially those validation-wise, so for the testing. And with that, I thank you. This is the link that I mentioned, Piacere Project EU, and see you there. Bye-bye.
Next, it comes another exciting talk of the day. We have with us Kamesh Sampath. Kamesh is an author, consultant, and developer advocate at Harness. He is a director of developer advocacy. He is also a Google developer expert for Google Cloud. Today, he is here to talk about everything cloud native Java, CI, and GitOps. Over to you, Kamesh.
Hello and welcome to this session on how to do GitOps with Cloud Native Java. Before we get into the details of this session, if you want to have a copy of the slides, you can get it from the bit.ly link bit.ly/java-ci-gitops, or you can simply scan the QR code that you see on my screen to download the same. Myself, Kamesh, I'm a director for developer advocacy at Harness, a long-term open source contributor and a Google developer expert for cloud Kubernetes. If you have any questions on this session, please feel free to reach out to me on my social handles, which are as QR codes on the screen. Let's get started. Once upon a time, there were a bunch of Java developers just like us who wanted to deploy the application to production. They were working on a feature release the whole week, and on a Friday evening, they sent a request to deploy the application into production. In those days, the release procedure is to detailed document on how to build and deploy an application. When they are back to work on Monday, the developer is surprised to see the application is not in production. And as you notice from my slide, there's a huge discrepancy between your development and production environment. The development environment was done in Java Windows JDK 8 Wildfile 9 with MySQL database, whereas your production environment is RHEL 7, JDK 8 and WebSphere 9 and Oracle database. As you see, there's a huge gap between this. And because of this, your application is not in production. And this was actually a usual phenomenon in those days when you start to push your application into deployment. And in fact, it also started to raise a lot of confusion, right? Where is the problem now? Why did the ops team were not able to deploy? Did the development team give the right set of instruction to deploy, and much more, right? And this is what I call as a great wall of confusion. But Docker came out of the concept of containers, things started to improve. We then started to use the containers as a way to package and deploy the application. The same application that we packaged earlier could be done using containers as like shown on the screen, with guest OS, app server, custom configuration, and your var and everything put inside that. And then the developer has to do a Docker build to basically build the container, and Docker push to push the container into the registry. And all the operations team has now to do to deploy the application into production is to do a Docker run, pulling the image from the container registry and run it in the respective environments. The process of moving the artifact in this way became very, very easy. In fact, with many cloud providers starting to support containers, we started to move our application to cloud just by containerizing it. Again, Docker build and Docker push has become the everyday command for the developers, and Docker run was taken care by the cloud provider. As you see on my screen, we started to move all our monoliths, in this case, using the same approach of containerizing them and pushing them into the cloud provider. This strategy is called as lift and shift. It's an easy strategy kind of organization started to adopt because they just package it and move it into the cloud. And this, in fact, broke the wall of confusion. And we leaped into what I call as a container native application development. But this happiness did not last long. As monoliths or heritage applications became too fat for containers, leading to tight coupling, resource crunches, developers started to break down these monolithic applications into what is called as microservices and distributed them all over the cloud. Though microservices had great benefits, example getting new features to market quickly, they also created what is called as an operational complexity. That is, when number of microservices started to grow, running Docker build and Docker push became tedious and time consuming. The ability to orchestrate applications as containers, doing rolling updates, sharing ports, resources became hard to manage. At times, even doing rollbacks to previous versions takes longer than expected. In short, the release life cycle became complex and hard to manage. To an extent, Kubernetes tried to solve this operational complexity by orchestrating the containers together. But still, the core problem of build, test, and push containers to the container registry remains unsolved. As you understood, until a new image becomes available in the registry, we can't roll out new updates. So we started to search for solutions that will help us to solve this problem and improve the application delivery velocity. And yes, as many of you already guessed, it's continuous integrations that provided us with the solutions we are searching for. With continuous integration, we can have our sources built right from the version control system, tested, and pushed to the container registry with what is called as a CI pipeline. Then the build container images become available to Kubernetes or similar platforms to perform installs, updates, or by pushing images or pulling images from the registry. It's pulling images from the registry. With VCS in place, CI tools were even smarter to be able to listen to the CI events such as push, pull, and merge and start builds automatically. But wait, as we start to leverage containers as first-class citizens in our development stack, is these CI tools a container native? In other words, can they work smoothly with container native paradigms? Oh well, not all, but a few. And Drone CI, or Drone in short, is one such container native CI tool that can help us to perform the CI by orchestrating a set of containers in what is called as steps. And a sequence of steps make up a stage or a CI pipeline. While there are many cloud-hosted CI solutions, Drone itself is self-hosted, so you can run it on your own infrastructure, which could be a cloud of your choice, or data center, or your home lab. So you have a full control over infrastructure, your source code, secrets, and so on. Drone CI is so lightweight that we can start building right from our laptops. In other words, Drone brings CI to laptops. Once we feel our pipeline works the way we want, we can then move them to the team's consumption via Drone server. This gives development teams a seamless transition from development to higher environments without much hassle. With Drone CI extension for Docker Desktop, this entire CI workflow could be done with just a click of a button. Rather than me talking about it, Let's see that in action. To install the Drone CI extension, go to the Docker for Desktop and go to Extensions and click on Marketplace. On the Marketplace, you should see the Drone CI extension available for you. You can also do a search to find out the extension as well. Just click Install to install the extension. It should take few minutes for the extension to be installed as it pulls the Drone CI Docker extension image and install it locally. There we go. The extension got installed. We can go to the extension by clicking Open here, or you can also use the extension sidebar. So right now we have to go import pipelines. The import pipelines basically means that go to any project that has .drone.yaml file. So I already have a Spring Boot Hello World project that has this drone.yaml file. I'm going to click search, go to my local machine, go to my lab Spring Boot Hello World that has the drone.yaml file, and then click open to open that into my Drone CI extension dashboard. I can also edit this using VS Code button here. Just click on this. That will technically open your project on VS Code. Let's examine this drone.yaml file. What does it has, right? It says a type Docker, which means that the pipeline is going to build using Docker. And then I'm certifying like what platform I use. I'm on an Apple Silicon, so I say Linux ARM64. And then I just do unit test here using the Java Maven plugin, which is basically nothing but a Maven used here inside. And I'm also pointing that to my local Maven repository that I already have it running to make my build faster, right? And then I package as a jar and push image into the registry. And then once the image is there in the container registry, we can just do Docker run to run the image. Let's go and kickstart the pipeline. To do that, click on run pipeline. And I have to use trusted because I'm going to mount the Docker socket inside so that it gives the privileges for the containers that will be run by drone. And I'm going to use a network called as Nexus 3. That is a local network that I have where Nexus is running for me. The Sonar type Nexus Maven repository so that my pipelines can reach it. And click run. And that's it. In few seconds, the application should start running. In fact, it will take some time for the logs to come up. As you see here, the logs started to come up and it runs a test case for build. And then it's doing a test here. Let's wait for all of the stages to be completed and see and run the container later. The test is done. Now as you see, the packages jar is started. So this is basically starts the packages jar thing. And that should also be done in a few seconds. And then that's there. And then let's go for the registry, right? It's running so fast because I pointed to my Nexus repository here. But in case you don't have Nexus repository, it will take few minutes for the entire process to complete. And as you see, my application got pushed into my registry.localhost 5001 example hello world latest. This is exactly where we are going to run the image also from. Okay, let's go to my command prompt and go to the project and do Docker run. You see, I'm just starting to run the Spring Boot application that we just built. Open up another command prompt and then do call the application, and the application responds with hello stranger. And that's what we have said our greeting controller will do when I go to the hello world path. I'm going to the default path as stranger, and then that's going to use a template and then say hello world for me, right? And that's as simple as to start with the development workflow of building a Java application right from your laptops using Drone CI for Docker Desktop. We saw how easy it is to run CI from your laptops using Drone CI extension for Docker Desktop. Let's take a deeper look into some of the Drone CI jargons. How does Drone execute the container native pipelines? Drone uses a declarative approach using a file called as drone.yaml. As you see on my screen, that's a very simple drone.yaml that builds a jar out of your Java project. It has a kind, which says that it's a pipeline, and type, which says that it's Docker, which means that it's going to use Docker containers, and a name, it could be a logical name, it could be any name you want, it uses default here, and steps, a sequence of steps that needs to be executed as part of the pipelines. In this case, there's only one step, which uses Maven image and does Maven clean install to build your jar of your Java application. So how does these things translate internally to Docker paradigms, right? So since we say the type is Docker here, the Docker basically when you start running this pipeline, Drone creates a volume called as workspace, and mounts your current working directory into the workspace and does a docker run command using the Maven image that is given, and as part of that image it also runs these commands that are sequentially as a shell script. So as you see on my screen, that's the entire translation of a drone.yaml into the corresponding docker commands. When build environments are container native, we can leave behind a lot of frustration. Here is a hypothetical team that happens written in Java. They want to do some Selenium tests and uses PostgreSDB as a database and finally push this image into, let's say, Google Cloud Run. All these tools that we use here provides an official Docker containers. And each Docker container has appropriate version and tag, so which means that any point of time we can change the version just pointing to the corresponding tag. And since the declarative drone pipeline YAML lives in a Git repository, the team can try and change various permutations and combinations of their application without having individual build environments. And this is how it gets translated when you have a team that's going to build a drone pipeline that's a Postgres database, it is a Google Cloud copy, and then does a Maven build and does a Selenium test. And in fact, drone also goes to another step, improving the reusability of your steps, right? Let's say a team develops this particular pipeline. And in fact, the GCS copy and build steps that you see on the screen can be combined together into GCS copy and build image and then pushed into the organizational container registry. And every other team that wants to reuse this thing, they can just pull this image, alter the command or pass some extra parameters to make this thing work. In drone world, this is called as drone plugins. Drone CI plugins are Docker containers that perform predefined tasks and are configured as steps in your pipeline. Plugins can be used to deploy code, publish artifacts, and send notification and much more. Here is an example of using plugins. We already used a plugin in our earlier examples when you push the Docker image. The same thing is used here. We are publishing this a Docker image here, and finally we are notifying that on a Slack. I see a lot of theory right now, and it's time for us to get into an end-to-end demo where we'll use drone pipelines to build an image from a Git repository and push it into a registry and finally deploy this application onto Kubernetes. As part of this demo, we'll be deploying a simple Quarkus Java application. The application has one single service that's going to talk to a Google Cloud Translation service to translate your greeting, like hello world here, into multiple different languages and then send it back to the Kafka stream, and which will be then picked up by a REST resource and sent as server-sent events to the front end or web clients who it's connected to. So let's examine the drone.yaml file here. So it's pretty much the same drone.yaml that we looked at the first example. So it is a kind of pipeline. It's going to run using Docker, and then I'm using ARM64 here as I'm running on Silicon. And then this is going to trigger from a branch demo. This is the first difference than the first demo which you saw, because now we are going to run as part of a server. I purposefully disabled the clone, otherwise clone will happen automatically. So I just want to show how we can use a custom logic for clone as well. I'm cloning from a local Git repository. We'll come back to that in a second, what components are already there. Checking Nexus is available, and I'm passing the Maven mirror URL to Nexus, and then doing a Java build, and then pushing an image into the local container registry, right? And then what we are also going to do is that I'm also going to go ahead and then kind of enable this one so that we deploy this application. So I'm just going to deploy this application into Kubernetes. I'm just kind of doing that series of things, just similar to a scripting that you do, right? That's exactly like that. So I'm just using Google application credentials because I have to talk to the Google API. And then I'm also sending a kubeconfig content so that I can run the bunch of kube commands from within this particular step, right? Deploy, and then I'm using a custom image which has all kubectl and everything installed in it. And that's pretty much it, what we want to do right now. So let's go ahead and start deploying this one. I have committed this, and let's go to our console to see what all components are involved, right? I have a Git. I'm using a local Git server for convenience for demo purpose, but you can use any Git server you want. I'm just going to log into this. I logged into that, and then I have to enable, I've connected drone with Git using OAuth. If you see this one, that's what is happening here. So I'm just going to authorize this, and this is going to say user-1 at example.com user.01 and me something, and then submit it. And there you see, right, this is your drone dashboard, right? You see all the technically synchronize all the repositories that is there as part of Git here, and then it kind of gets in the here, right? We are just interested only in this one, which is right now. I'm just going to do an activate. You can also activate this using drone and see what happens to this. Let's go here to our demo, and then if I do a refresh of this, you should see all the secrets got added here, so everything is encrypted. You cannot see any of these secrets as well, and you can also add secrets at an organization level. So we'll cover more of these drone related stuff in its separate session or workshop, but for now, just let's go and kickstart a build here. So what I'm going to do right now is I've activated the repository. I have a commit ready for me to push stuff up. I've enabled these things here. So hopefully, let's go and commit this one here, right? Say fix, or I say init deploy, or I just call k8s deploy, and then I sync the changes here. Git push drone demo, and there you go, right? It's kickstarted the build here. So because I've activated the repository, I've given all the permissions here, and then kind of said, okay, push it and clone the sources, making sure his Nexus is available. The only part that could technically take some time is Java build, because it has to warm up the M2 cache for the very first time. So it might take a bit of time here in this case. So let's give us some time for the Java build to go through it, and then we'll come back and check if our build was successful. Okay. There we go. Our Java build is done, and then we are getting into the publish mode right now. So I kind of skipped through the Java build stuff here because it technically downloads that. Our new build should be much faster than this one, as our Nexus repository is warmed up now. So let's wait for the push publish to be done, and then the deploy to Kubernetes will happen. So we are good here. So it's kind of going and doing the job. It's kind of pushing the things up. It's pulled everything right down, verifying checksum, all these stuff. So this technically takes a minute or so for the publish to happen. So let's wait for the publish to be done, and there we go. The push is done here. It's kind of pushing to the local repository right now, which is again hosted on Nexus for the demonstration purpose, but you can have your container registry anywhere you want to, right? So it's all configured using secrets. If you imagine that we added a bunch of secrets, one of those secrets were image registry user, image registry password, and all these stuff. And there we go. We are all good here. The image got pushed into the registry right now. And now our deploy step is basically going to deploy this application into our local Kubernetes cluster. I'm running a K3s cluster using K3D. So I have all these links as part of my README, right? If you go to the repository here, github.com /lingua greeter GitOps. So if you see this repository, the README has all the information. You can completely reproduce the entire stuff yourself. And these are the two repositories. The links are again there as part of the resources slide. You can go there as well. So it also has all the links, all the tools that is used as part of this particular demo. So let's go there. Let's wait for the thing to come. The one of the things which takes time is technically is going to be Kafka, because it takes some time for Kafka to come. Then we'll try to port forward the service and invoke the service and see if all went good, right? So I said again, so all these are there, and then you can also find some good plugins at plugins.drone.io. There are a lot of community plugins available, and I have contributed the Java plugin here, which is a set of properties that you can use. That's the one I'm using as part of the demos that I showed you. There are other plugins also available. If you want to contribute some plugins as well, please do so. Send a PR to us. We'll be happy to review and merge it. All right. So let's see what happens here. The Kafka is still getting there. So let's wait for Kafka to be done. And once Kafka is ready, our Greet application should be deployed and the pipeline should complete. Right. So let's give us some time for that to happen. There we go. It got deployed, and then we are good here, waiting for the greeter application to be deployed. So let's wait for that also to complete. And there we go, right? Our first CI using drone CI end-to-end deployment of a Java application is done. Let's go check the application. Let's go to the terminal, and then I say kubectl get spots on my apps. Okay, you should see a lot of pod, right? There's Kafka, which we deployed here, and there is a service which technically is Lingua Greeter that we are interested in. So let me do a port forward, port forward. I just use my app's namespace here. It's getting port forwarded. Let's go to the browser window and then open up the application. I say localhost 8080. And soon you should start to see the application greeting you hello world in multiple different languages, because that's what the whole application is all about. There we go. So it starts with French this time, and then it says in multiple different languages. It's in Bangla, and then should have a few other Indian languages coming up, Chinese there as well. So that's the thing, right? So we got deployed. We did an end-to-end deployment of the application this way, right? Let's see what happens if I go change something and deploy it, right? It should pretty much do the same, right? Let's go to the application properties and say hello OSCONF, right? So let's say it's this one, or hello, yeah, that's good, OSCONF. And then I'll just do commit and push. Sorry, there's an O missing here. And then I say git push to, and then I should push to demo drone. And in a second, you should start to see the build happening here. If you go back here, there we go, the hello to thing. This time it should be blazing fast, right? I expect that the Java build to take something like 14 seconds or something. That's a usual time which I measured when I was doing the rehearsals for the demo. I hope that hits the same timeline, or yeah, there we go, like 14-15 seconds. And then the publish happens right now. That's also goes through. And mostly in my case, my deployment should fail in the deploy KATS, because what I have done here is that, okay, good, I just did an upgrade, so which means this should also pass through, right? And publish, again, it's pretty much the same process as we do the publish here, build and deploy the application. And let's wait for the, if all goes well, my port forward should be kicked out, because there will be a rolling update happening to the application, and things should go through. Let's wait for that to happen. Publish. It's pushing into the registry for now. Let's see if the registry has all the things done there. Let's wait for it. There we go. So it starts to prepare. Push, publish is done. Well, great. And it should be faster right now because we already have Kafka there. So the Kafka is done and deployment is also done. So which means if I do a refresh here, so this should technically come back to this. And let's see if my application got deployed. Well, okay, let's see. It's still not there. So let's wait for this. Okay, get pods, FNN, my apps. Let's see, it's still there. I don't know why the application push is not done. Hello, welcome to reactive programming. Okay, I have to do this rec rollout. Since this cannot automatically do, I have to restart the application to pick up the new image. FNN, my apps, deployment greeter. Let me see if it's coming up. Yeah, this is what it is. Let's see if this is coming up. The other one is getting terminated. Let's do a port forward. And it should get it through. Yeah, there we go. So our image got updated. So the whole thing what I did right now is kind of did a restart of the deployment, because the application doesn't pick it automatically because it's not a CD. We'll come back to CD in a second. But since it's a CI, so we have to do all these restarts again and again, right? So that's one of the things where we roll out, there's no automatic rollout of the application happens unless and until the deployment changes. That's the nature of how Kubernetes work. And that's pretty much we have here for this CI piece of the demo. Let's get back to our slides, and we'll come back to another demo, another few minutes, where we'll show how to use GitOps in place of the CI scripting that we done there. Though the CI pipelines that we saw as part of the demo achieved what we want, but it has its own shortcomings. So let us see what are those shortcomings when we start to use CI tools like Drone or any other tool for doing CI CD. The main shortcomings are like they become hard to maintain, right? Because like when you saw right now as part of the step 4, we kind of included lots of Kubernetes commands inside the steps to deploy our applications into Kubernetes cluster. That could be the same thing to any other platform that's not even Kubernetes, where it uses containers. And secondly, if you see, like we are mixing the code and infrastructure. So the whole job of CI, in my opinion, is to just to build your sources into container image, right? And it should not do all other kind of work like deploying the application, doing all of that stuff. Though it can do, but it reduces your maintainability of your scripts, right? And again, so we have to keep it separated, that your code and your infrastructure are technically separate always. As I said earlier, the same thing, mixing in code and infrastructure also causes a reduced reusability, in other words, I should say. So there is no consistency. Synchronizing across multiple clusters becomes tough. No deployment history, though we'll have build history as part of CI, but there is no deployment history, like what version of manifest got applied to the previous version, right? So we don't have an history of those things maintained as well. Again, there is no credential management, though Drone manages your secrets and other stuff via your repositories. But in case like you want to avoid even that, like we want to keep it abstracted to only to the admins to know what secrets are available to the users. Just it needs to be available. The user does not need to have an access to it. So that becomes harder as well. So all these constraints could be mitigated when we split CI and CD for cloud native applications. So what I mean by that, we start adopting strategies like GitOps, like a version continuous deployment kind of thing, to kind of start doing all our continuous deployment kind of thing. Typically what I mean by continuous deployment is deploying manifest or applying manifest onto Kubernetes clusters. So which essentially means I will stop scripting like what we did in the earlier Drone pipeline and start shipping more, like, which means that the moment the image is available in the registry, I have tool like the GitOps tool like Argo CD, which kinds of picks up the manifest from the Git repository and starts applying them using the latest image versions or image tags for that matter. So which eventually means that we get a lot of advantages when you start to use GitOps for CDs, like deploy faster and more often, right? And then easy and faster error recovery, because everything is Git, so we can roll back the versions anytime we want. Easier credential management. As I said, tools like Argo CD have centralized credential management, which will allow us to have RBAC applied on top of them, so that only the people who needs to know will know it, others technically does not know about it, right? Again, they are self-documenting deployments, because like everything is manifest or YAMLs, Kubernetes YAMLs in this case. So which means that people do understand what they mean, and again shared among the system because everything is in Git, right? So I'll stop talking here, and then let's get back to another demo where we'll see how to kind of apply or deploy the same application we saw earlier as part of the CI demo using GitOps principles. We now understood the shortcomings of CI being used for CD. And principles like GitOps could be more effective when we want to do continuous deployments for cloud-based applications. In fact, we found that out when we did the CI demo, where I have to manually roll out the application when the image change happens. As part of this demo, we'll apply the GitOps principles using a tool called as Argo CD. You can read more about Argo CD at this particular site. I've also added the link as part of the resources, as well as the demo repositories also has links to this one. So let's get into details of what Argo CD does for us. So let's log into this. So I'm just going to log into Argo CD demo at 1.3, and there you go. And you're surprised to see right now the applications we use so far. Your Nexus, your Drone, your image updater, your Docker runner, which built your application, etc., were already being deployed using Argo CD. So this is what I call this as drag stack. Basically, like it's Drone, Argo, any registry, and Git in Gitty in this example. So this is one of the ways by which we can start to build our own continuous delivery platform using multiple different tools that is available as part of the CNCF Foundation. All right, let's jump into demo and deploy the same lingua greeter application using Argo CD. So let me go to my VS Code here. The very first thing I have to do is that I have to create a bunch of values for Helm. That's what I'm going to do here. So let me start here and then go open another prompt and go here. And technically it should all remain same because that's what I did when I kind of rehearse this demo. Let me see if all good. Okay. And then this should, since everything is clean here, I'm just going to introduce a empty commit. Hello empty, and this I say init GitOps. I'm gonna say git push GitOps main, and this should technically push my application into my Git repository, right? And then what I'm going to do is like I'm just going to create this application that's going to deploy my Argo CD application. This application got created. If you see here, it deploys a Kafka for us here as part of the same thing, and then the Lingua Git application is getting created here. So obviously the application will not start up because it depends on Kafka. So let's give us some time for this application all to be synced and be healthy. So we should see healthy and synced for both these Kafka and Lingua Git. The Kafka is getting deployed on its own namespace, Kafka, and we are choosing a different namespace called as demo apps for this particular demo that's getting deployed with Argo CD. So while this happens, what we can also go and do is like, let's go and I have initiated a commit, so which basically comments the old deployment of K8s that we did last time. And I need to do a small preparation here. Actually, this should not be needed, but this is only for demonstration purpose, that I need to create this application credentials in the demo apps namespace. That's what I'm going to do. I'm just going to say per GitOps. And then I'm going to say sync changes here. And that should technically trigger another build here, right? The prepare for GitOps thing, which happens here. Let's go and see what happens to our thing. There we go. The greeter is still waiting for Kafka to be ready. So let's give some time for Kafka to be done. So let's click this and you should see this application is still waiting for Kafka. It says still the container is creating because there we go, right? The application got created because let's go and see Kafka as well. Okay. Yeah, Kafka is healthy right now. So which means that my application or application should already be ready as well, right? Let's click on this, but obviously this will not be ready because it might be looking for the credentials, which it doesn't have. Let's see the events. Yeah, there we go. The Google Cloud credentials is not there because we have not created it. So that's what we did as part of the build step right now here. So once this build is done, the new image gets pushed into the registry, which technically does not have any changes. But the prepare for GitOps should create us all the secrets that is required, right? So then this particular thing should come up, and there we should wait for some seconds to see if this goes up. This is 2 minutes, this is 1 minute, and you should see the sync happen automatically right now. Let's wait for a few seconds for this to happen. So because right now the secret should be there, so when the container gets created again, so it should continuously keep syncing for the thing, and then once it's created again, it should start to see the stuff coming up for us. Let's wait for that to do. Sometimes when you're impatient, you can also go and do the hard refresh here, but let me do that for this moment. Let's see if things get picked up. Not sure. So let's see. It's the same events as here. That's right. So it's not healthy. So let's give some time. There we go. So it became healthy right now. The old one gets terminated. We're not worried about that. So let's go and do a port forward here. Okay, port forward. This time I'm going to do it from my demo apps namespace. Let's go there. And let's go refresh this one. Obviously, we should get back the hello OSCONF again because that's the latest change which we introduced to our, there we go, right? Namaste OSCONF, that comes here. And we are good here, right? And the thing which you're going to do right now is interesting, right? So I'm just going to go ahead and do a change to the code. And let's do it here. And say, thank you, OSCONF. And then I'm just going to say thank you, commit, sync the changes, obviously. And then I should have another build triggered here as part of our pipeline here. There we go. Say thank you here. Java build, publish, and push to registry. And we should see an automatic rollout. This image has started at like 3 minutes ago. So let's wait for this. I think once the image got pushed, our latest changes should be picked up automatically by Argo CD. Though there is a sync interval, I will see if the sync interval happens within the time. And then that particular changes should come up, right? There's a publish happening here, which means that my new image is getting published. And let's wait for that to happen. Yeah, it's getting pushed right now. So let's see what happens to the application here. So nothing should change here as well. And mostly the change should happen here. So you should have a new sync up happening here. So probably a new commit or something should be picked up automatically, and then the synchronization should be done. Okay. So let's wait for that to happen. So let's see, okay, the build is done. Everything is good. The new image is there in the registry. And let's wait for this to happen. I'm going to give it a few minutes this time for this to happen automatically. So the sync interval, basically Argo CD kinds of pulls these images from the registry whenever there is a change. So let's give it, there we go, right? So we saw the new thing getting created here. The new image, obviously we'll also see our port forward got kicked off because there's a new rollout happening. So let's wait for this to come up, and let's see if I'm able to do a port forward now. And let's go back here to the build greeter and see what happens here. It's still there, the old one. There we go, the new welcome. There we go, right? So you should say, I hope this is, I don't understand Korean though. So, but this should be thank you. Let's see what happens. Let's see in a different language. So what happens here? Okay. So that should be our new image that should technically be there. So let's see that thing happening. Okay. So the port forward is dropped. Let me go in here and see what happens. Actually, then my other glues, that's there, right? The new thank you OSCONF has greeted us here. So which means that with GitOps, I was able to kind of do this automatic rollout of these applications without me touching anything, right? I'm not even running kube commands here, right? I have a Helm chart which does this, and our tools like Argo CD are able to understand how to kind of pull this thing up and do a rollout and all these things. And in fact, we also saw that we're able to get the base stack already up and running for us, so that we have the stack ready in each cluster the moment we say go, right? This also helps you in easy recovery, and technically a disaster recovery kind of thing, to recreating the whole clusters. And that's pretty much for this demo. And you saw how we can use CI plus GitOps to do Java application deployment into cloud. This is what I mean by java-jar equal to CI plus GitOps. And thank you, and I hope you enjoyed the session. I know we learned a lot in this short time, but just to summarize what we did, we understood the evolution of software delivery, why CI is important for efficient and automated software delivery, picking the right CI tool like Drone CI that can understand container native paradigms, understood the shortcomings of using CI for CD, understood how to use GitOps as a continuous deployment strategy, and finally, built a tool chain that could help us to build our own continuous delivery platform. Please don't worry, if you want to learn more, please do join us on our community Slack, harnesscommunity.slack.com, and you can hit us on Drone or DragStack channels where we'll be happy to help you. If you loved this session, please do give me a tweet love. You can just tweet using these handles that you see on my screen and hashtags. And you can also scan the QR code here to get to the GitHub repository of this demo. And finally, I thank OSCONF for having me in. I hope you have a great conference, and thank you so much.
Okay, so it's exciting to see so many great talks happening on the single OSCONF day. Without any further delay, let's move to our next speaker, Jonathan Gill. He is a system engineer and software developer. He loves Linux and the philosophy of sharing his knowledge with the community. Today, he is here with us to share his learning and experience around observability in DevOps. So let's welcome him.
everyone. Welcome to this talk. We talk today related for observability, one of the strongest muscle DevOps. So we start talking about that because in my experience, normally we found a lot of tools that use implementing DevOps, but not appear something similar for observability. How to you can start, how to this open your eyes for how to your infrastructure or something like that works for you, and it works well for your current company. And this it's very helpful for every day that you make something new in your company. So let us talk about that and more in deep how to this works and how to the help a lot in our companies. So let's start to this presentation. First, introduce myself. Who is Johnny Pong or Jonathan Hill? Just a human that loves Linux a lot in all the sources, I think, and how to you can move around for the community, how to you can teach, how to you can help, and how to the community can help to you also. So it's very impressive for you. I'm very passionate with technology in general, especially for make more easy your day in every day that you take your challenges in your company, and also how to you can deploy in some infrastructure like a locally or bare metal or in cloud infrastructure, and how to you can move so fast in these environments in every day. So that is me. That is how to try to do this something every day. But let me share my social network. You can find me in GitHub, YouTube, or Twitter, like at jtan24. You can find me and follow me. That is my social networks, and I share a lot every day, especially in Twitter, for fun stuff, for technology stuff, for pets stuff. That depends. That it could be like my Twitter could be works for you. So let me share with you this really awesome quote about your life and our lives. That is, the life is really simple, but we insist on making complicated by Confucius. That is very awesome because some days you have a lot of new challenges, but without a good perspective for the challenges, you could be take more long time try to do something to implement that, but not every it's so easy to do that. So that is for objective for this race, especially for me, because could be the work that takes for you could be 5 or 10 minutes for your day. You try to do something about the scripting, generate this scripting could be take for you 1 week, whole week. So it's very easy. Take that time and generate your task more easily in manual mode, but you insist for generate this task more for the scripting, so you take more long time that could be the task needed. So that is you need to put that in balance in take with respect your time and take these 10 minutes or 5 minutes. What happen if you create that script that could be take for you the 5 years or 5 days? I don't know. Could be it's more easy to you take that time for your everyday. That 5 minutes could be works for you. So let's move so fast for the agenda. Today we're talking about the what is DevOps, a general scope about DevOps. Talking about the maturity model for DevOps. What is observability? What is the golden triangle that it's around for observability and how you can use observability for yourself and your companies. Why observability? Because we need to define why observability for us. We're talking so fast for CNCF. I hope you learn something about that, or it could be we take a little time for talking about the CNCF and how we can move with that. And the end, we can check a little demo about the current implementation for us. So we'll continue for that. What is DevOps? DevOps is a methodology in which teams own the entire process from application development to production operation, hence DevOps. It goes beyond implementing a set of technologies and requires a complete shift of culture and processes. DevOps calls for a group of engineers that work on small components versus an entire feature, decreasing hands-off, a common source of errors. That definition was taken from glossary, from CNCF also. The CNCF, it's community behind of the how we can move around the technology, and it's exactly for the Cloud Native Computing Foundation, and how we can move so fast for our companies, and how we can move inside of this CNCF community, how you can use that the community for doing something more than easily for you and your company. So you can check a lot of that for that, and you can contribute in your glossary or something like that, and just generate a pull request in the GitHub repository for your languages. Work for you, work for your community, and everyone appreciate that you can do for your community. So the next step we have in a big scope, that this part, that is the methodology, teams, technology, culture, and process, that it could be the most strongest that we can use in this DevOps model in a big scope. With that, we can talk about the maturity model, how to DevOps you can use, how you can define in your company if we have DevOps or not, and what is my current level for my company, and how we can use exactly DevOps. So we have the first part, that is initial model. In your company doesn't exist a DevOps, doesn't exist a CI/CD definitions, because in general we have a CI/CD definition, that is CI for continuous implementing and CD for continuous deployment. But how we can use that inside of our companies, that is the best part for you. So we in this level, we identify that we don't have DevOps in our company. So that is the first part. Identify what is the current level for us, and how we can move for the next step. That is the how we can use and implement that maturity model. So in this model, every that you can grow up in this model, you need to identify what is the next step and how we can move for this next step, and using the correct path for you, because depends a lot for your company, depends a lot of your culture, depends a lot of your processes, and how you can take that and move for the next step. So in the initial model, you have a lot of silos. You deploy in a big picture and a wall for component. For a new feature, you have a lot of a lead time, that is the time that you take from one requirement. What is the time that you're taking from the requirement gathering start, and how do you come, what is the time that you put that requirement in production? That is the lead time. What is the current time that we taken for generate this in production? So in this part, you have a lead time, very huge time also. So you identify that this definition, it's very difficult for generate. Could be a deployment in a week, could be our deployments works for a month or 6 months, or could be for a year. That depends for the how to your company and your processes works inside. So for the next we have in a next level, the managed level, that is start with DevOps. That define some part of the CI and the part of the CD, and the biggest part for manage it for this level. You have an operations and development teams works start to work. So in the initial model, you have in your company something like we mentioned, like a wall of confusion, but that is how to dev uh, dev team and operation team works. Dev appears in one part of the company, and operation works in another part of the company, and they works everyone for your path. So it's very difficult try to generate a best communication inside of that. So it's very hard for they communicate in a good way. So in the next level, these areas start to working together. It's more easily generate this communication, how to devs communicate for the ops, how to this generate something like a cohesion for the current implementation, and it's very helpful for these teams and generate more valuable feature for the company. So in this part, you have a lot of challenge in all company, because you need to move the culture, the processes, the how to the teams work and how to the teams communicate for that. In the next step, you have a defined, you have a DevOps defined model, but your process could be is more hard to move. So you have in next step for move in that. So you have a DevOps teams, you start using some tools for generate more valuable for your company. You could be use CI and CD pipelines for deploying some environments, and you have could be part of board how to you can document in your processes, how to the dev team works for around the current infrastructure, and how to they new guys could be use a new git for implementing new features. So in this part you have a good model, you have a good level, but you could be take more at the next level. In the level for DevOps, this is there that it's one at a time. It's very easily identifying your company. And the next step is how do we can define, or we define this part of like a measure process that is start a journey to automate path that using monitoring tools. That is talk about the one of the biggest pieces that we talk in this chart, in this talk, that is for the monitoring tools. You define a current path that how to you can obtain a lot of information from your application, information about your infrastructure, from your network, from the all components around for your application, and how to you can obtain that and take this information and put all together in one part of your company, and could be start to generate this size inside your infrastructure for your application, and take more intelligent decision around the infrastructure, around the technology, around your networking, around your application also. So in the next step, we define optimized maturity, and you have a big cohesion for all your teams. You're talking about the dev team, the operation team, also the QA team, and other teams that involve for the CDLC cycle, that you have a lot of people around that, and you use these people, use these teams for generate this big cohesion, how to they can work together for generate more valuable software, more valuable feature for your customers, for your company more easily. In this part, you have two excellent bonus for that, because you have and you involve a lot of the error for your new features. You start to fail fast in your company, and it's normally in this part, because if you talk about the error in the initial model, you have your process, oh, that is taken error, so we have for the bad way. No, the error is a normal way, but in the initial model it could be we have more difficult for talking about the error, because it's very hard. You have to move your teams and how to you can move this team, and talk about the error could be generate biggest noise here before that you try to start with DevOps. So it's very difficult to start to talk in initial model for the errors, but in the optimized you talk about the error like it's normally, because the error every day we can exist, but how do we can use the error for move so fast for generate the new feature around our software and around our company. So you have a lot of the teams behind of that, and how do we can identify so fast this error, how do we can fix that in our environment so easy. That is the difference in every steps for this maturity model, but depends for your company, depends for your teams, and how do you can use that for doing more easily for you and your teams. So with that in mind, we can move so fast for start for observability. Observability is the capability to continuous and generate and discover actionables inside based on signals from the system under observation. In other words, observability allows users to understand a system state for its external output and take corrective action. Right? So, in this case, we take the same definition from CNCF and the part of the glossary that we have a lot of definition around that. So, with that in mind, we have also the observability, we have observation, we have signals, we have a system state. How do we can take that around for our software or our components for support the application, and how do we can move so fast and identify could be some possible errors for our application. So, for example, we have this coil triangle, right? That is the golden triangle for observability. We start with logs, we start for metrics, and we start for traces. But what is everyone for this part? Logs in first is the part of the how to we can have the logs. That is the retrieve what happened with your application, right? Because you put could be a console.log or console.error or console.info, that how do we can obtain this information from the application. And it's the first part that could be the application sends to us and identify what is the current state for our application or the current state. That is this part. Normally you have a lot of information about that, and how do we can obtain this information and put in some part. That is the one part. Second part, metrics. The metrics contains information and average about the service or application, like a CPU memory, like a RAM, like a disk usage, and other information out of the scope for the application. We have a container or virtual machine and what is the part for the my application, and what is the part for the operation system, and what is the part for the hardware. That is the could be we can obtain, and what is the part that we need to obtain that information for makes sense for us, how do we can obtain these metrics, how we what is the best part for it, what I can do with these metrics. The third is the traces. The traces is information about the transaction with unique IDs for generate correlation with other events that happened in this transaction. For example, you have a microservice model. You have a one service for one part, other service for other part, and you need to communicate service A with service B. How do you can define the transaction from service A is the equals for the service B. That is the trace that start to generate this information for you and your team and make sense what happened with that transaction from one service to other service for your broker, for the database, for the all components around for your software. That is the objective for that. With that in mind, we have why observability. Yep, we have in this part a little concept around your application. You have one application in that part. In this part, you have your application, you have the database, you need to send data to save in your storage model, and you have balancers here, you have two inside for something like that, you have the cloud, and you need to your customers use your application and consumes your application inside of your networks, could be in cloud model or in bare metal or on-prem definition, depends for your company, but you have these components every day. How do you can define that the user transaction access to the database or take one file from your storage definition, and what is the action that they take in their software. So it's so difficult to identify in the first view this application and how do the users consume your application and takes that from your application. So that is the second model. We have our customers, we have our application behind it, could be in a microservice model, but how do you can identify that in this part the firewalls down, the applications down, the storage down, the database down, the my load balancer down, or could be the my cloud provider down. I don't know. You need to generate your eyes inside for your application, but not just for your application. You need the eyes inside for the all components behind of your application. So you need eyes for your application, for the database, for the object storage, for the balancers, for your networking, for your cloud provider, for everything that you provide for your application and makes sense for your customers. So that is why observability. I think with that, we identify at this moment that observability is important for us and is important for a company. More than could be how do we can deploy, because we need to generate this size, because operations teams and dev teams make sense that they have eyes inside for the current information and how do they can obtain more easily for they and use it that. So talking about the CNCF landscape, about what is the current tools behind observability, we have a lot of tools for private cloud or public cloud, for private providers, for public provider, for community providers. So you can visit the CNCF, this landscape focused for observability and monitoring tools. We have a lot of resources about that. We have from Amazon, from AppDynamics, from Cortex, Datadog. We have Hexagon, Falcon, Instana, log monitoring, Nagios. You have and found around that a lot of tools depends for your focusing. In this part, we're talking about the monitoring. In this part, we can talk about the logging. In this part, we're talking about the tracing. In this part, we're talking about the chaos engineering and continuous optimization. And you have a lot of set of tools inside of the CNCM landscape that is the community for our community, and you can use that for take your right decision inside of your company. So that is very easily to identify what is the best for me. You have behind of that a lot of people that takes that POC for you, and could be these tools cover all your needs of this unit. Don't cover all your needs. You can also generate your PR, and with your PR cover your needs for you and your company. So you can do that. That is the objective for the community. So with that in mind, we can move so fast for our demo. In this demo, we're talking about, well, for one part of for Docker, and generate in one part one application based on in JS mode that is up a one server using JS. In the other part, we app one application based on Python, and the end of that we generate observability for all components behind of that. Yeah, right? That is objective for that. We have in this part the current instruction for generate this demo in your homes. Please don't run that in production, please. I recommend that. And start with that. So let's begin with that. So in this part, I clone the repository. We have the current application, so we can move so fast for the O1 app and start with that. The objective for that is app and create this application. We need to compile the current application. We execute this command here. And we generate the current application behind of the Docker file and using the app.js and package JSON for generate the current images for your application. For example, you have the login portal, you use the front-end application that generate these resources for your company, right? And that is, and it's moved so fast. That is the first part. And the second, we can move so fast for a Python application. Okay, we need to move and run this application. We build the application. The next step is continue with run the application. So with this command, we execute the application, we app the current application and expose the port 8081, right? For our application that expose internally the 8080 port. So we can move so fast for the 02 application. Okay, cd O2 application, and the same we can move. So we have actually here readme file also, and we can create my Python application and execute this command. That is very easy, very simple for this, but could be your application need to generate more steps more than this that I propose in this execution. So this part just taking the requirements files, that requirements.txt, and obtain that information and compile the current information. Could be this your backend, could be. And with this part, we execute the current application and we run the current application. So we can move to the previous file folder and we can execute the Docker PS. With that, we identify that the current application is executing now. We have the current application running in our server, and it's very well. We can use curl for checking that. So we can use curl for that. HTTP localhost for the port 8081. Okay, hello world and 8083. Hello world, this is my password. The secreto mejor guardado. So with that in mind, we have actually a Docker. We have, and in this part, this point that it's executing. But what happened if my Docker could be works wrong, or could be my part of communication doesn't work well? So we can add it for this Docker observability for how to our application it's executing now, and how do we can use that execution for us. So we can move so fast with that and use the file here, readme, and we can start with this. So we can clone this part. Already done this before. Access for the current folder and execute this line. So that is the current line that we can find in our repository also. And we execute the current line, right? In this part, the Docker file generate your scope for observability, and you can execute Grafana, Prometheus, and a lot of service behind of that, and obtain metrics for the current components, and obtain metrics for the base for components for you, and generate this information for you. So in this case, we access for this Grafana. In my case is for this IP, and you can use the IP that generated, or could be if you put all together in the same machine, you can use the local host, and you can explore the current browse, the current dashboard that exists here, that is for Docker containers, Docker host, monitor services. So with that, we have a lot of information about the current execution for your Docker. So we have the CPU, the memory, the storage usage, and the running containers, the system load, the IO usage, the container CPU, a lot of predefined panels for you, and you can take more in-depth information for your execution in that Docker. So in this part, we have the Docker host, we have what is the time running this Docker, CPU, the CPU cores, what is available for our resources, what is the current information about our pods, about our container, sorry, and what is the current execution for IO users, the network, the swap IO, a lot of information around the current CPU, the current infrastructure behind that. You have inside of that services, we have some services behind of that, a lot of information also for that. And also we have that other perspective for the observability. We talk about the one part, how to you can monitoring, how to you can obtain these metrics, how to you can take their signals for generate observation and identify the system state. But the other part for observability is how to you can take these corrective actions. So with Grafana, you can access for current alerting. In this part for alerting, we have information about the how to you can alerting about the Docker, how to you can alerting about the rules for the host. If you had a high or lowest level for your memory or CPU or storage, you can generate some alerts around that. How to you can generate these alerts for your correct teams, how to the teams could be execute some scripts, and how to you can with observability generate the automatic way for all your painfuls that you have in your infrastructure. So it's very easily for you take that action and make more easy your work for and the job for your coworkers. So that is the end for me. That is the end for the demo. I hope you learn something new for that. In a brief resume, we have observability. Yes, we need observability. We're talking about today about the DevOps and maturity model, observability, why the golden triangle behind of observability, and we talk about the little demo. So I appreciate your time. Thank you for your time, and I hope you learn something new. And see you again in another talk. Thank you. Bye bye.
Well, that was an interesting session altogether. In case you have any queries, feel free to ask in the chat window. Let's move further with our next speaker, Kustuba Shravan. She is a senior SRE engineer working in Dell. She has overall 12 years of experience and have been using cloud technology in her organization. She has completed many certification in all the leading clouds like AWS, GCP, Azure. In total, she has 26 of them together. That's massive. Today, she is here with us to talk about the fundamentals of Kubernetes. Here we go.
Hi everyone, welcome to OSCONF 2022, and my name is Kaustuba Shravan and I'll be speaking about Kubernetes. I'm a senior site reliability engineer in Dell, and I'll be giving a talk about introduction to Kubernetes and what are the easy ways to try out Kubernetes. So let's get started. A little about me. As I told, I'm a senior site reliability engineer at Dell, and I have some 8 certifications in Azure and some certifications in GCP, AWS, VMware, as well as Dell and ServiceNow. So let's get started into what is Kubernetes. I'll give you an introduction like how the Kubernetes is born and what type of problems it's going to solve. So Kubernetes is also called as K8 because there is like 8 letters in between K and S, and it's an open source system for automating deployment or scaling, and it is used for management of containerized applications. It is actually a CNCF graduated project, and it was born out of the Borg and Omega. Like Google created this for solving the large scale problems internally, and maybe they still be using it now also. And it was launched in 2014, and it is not fairly old like any programming languages, but it is not new also. People are learning Kubernetes, especially when there is a lot of containerized applications and everything you need to know, and it is the need of the hour, and you'll be having a very important knowledge like when you're learning Kubernetes, and it adds an A plus into your resumes, as well as you'll be learning many important concepts of what type of problems Kubernetes is solving. So I'll be giving an introduction to the types of problems it is solving. So let's it is actually designed to scale, and it is designed to run anywhere. It can either run in your Raspberry Pi as well as in your perimeter systems, or it can run in your laptops. So the flexibility is given by Kubernetes. So why Kubernetes? Maybe most of you are familiar with Docker. Like we had a container, and Docker was running in it, and Docker file was inside the container, and Docker build used to complete the image, and Docker run used to be done. And what happened here was, let's take an example of any monolithic application. Like we can take an example of the flight booking service. Like it will have many microservices involved. Like for example, if this is a flight booking service, there are thousands of many microservices involved in this. For example, one might be the page about the payment gateway, whereas another will be the flight search gateway, and there were many things involved in a application. So if you want to have availability of this application, like if it is a Black Friday sale, there will be a huge amount of demand for this service, this application, and if there is any downtime, and how is it like we can bring back the service, and auto scaling. Like as I told you, if there is any Black Friday sale or any other thing, like how can you bring the availability and auto scaling of this application. And scheduling, what how do you monitor this? You may say like custom scripts are available. Like for imagine if you have a service which is having thousands of if you have an application which is having thousands of services, you can't write custom scripts for each and every application. That would be very tedious jobs. And getting metrics is also very tough. Like if you have everything as a separate containers, and you will have to take care of the metrics for each and every container. Like if you have thousands of containers like this, I will have to write custom scripts to get the metrics for each and every container. So these were some of the problems everybody were facing, and that's where Kubernetes came into picture. As I discussed you in the previous slide, like microservices were introduced to tackle the problems which we were facing in the monolithic applications. Means like every application component will run as a separate container which will be running together. When designing and running at a large scale, these containerized applications will require hundreds of thousands of containers. So each microservice will be running in a different way, and each microservice will be requiring scheduling, networking, scaling, and that is where orchestrated came into picture. So what does an orchestrator do? It's like container orchestrator will reduce the operational effort required to run and containerize the workloads and services. Like you can do the updates within no time, and scaling up and down. Like as I told you, if there is any Black Friday sale, or if there is any you can say like if there is any important days like sale days, or if there is any downtime, like if one of the servers are down, so bringing the other one up and keeping the application available always. And it provides security and reliability and self-healing of the containers. So that is where orchestrator came into picture. So since we have learned about Kubernetes, since we have understood where Kubernetes is used, we'll start learning about the components of the Kubernetes. So Kubernetes has two components, the control plane and the worker node. And a cluster is created when you deploy Kubernetes, and control plane and worker nodes are present in this cluster. Okay, what is this control plane and worker node? And I'll be explaining each and every component of Kubernetes in next few slides. So let us first learn what is kubectl command. Kubectl command is a command line tool that is used to interact with the cluster. There are two types of interactions which we can do, as I've shown it. It's either imperative or declarative. Imperative in the sense we'll be running the specific commands in the terminal and sending a certain set of commands for the Kubernetes to perform. Declarative way is where we'll be writing the YAML files, and we'll be giving all the instructions regarding what has to be done, and we'll be running those YAML files and sending the instructions. Now let us learn what is the control plane components. Like as I've shown you, control plane has like 4 important components, like the API server, scheduler, and control manager and etcd. The API server is like the brain of the Kubernetes. It receives all the information from others like control manager, scheduler, etcd, and it sends instructions to every other component in the control plane. And for example, if you're running kubectl run nginx, image is equal to nginx, API server will send this. API server will be sending this instruction, and it is like it does 3 types of work. It does the authorization, authentication, and admission. Authorization in the sense like it will be checking if the person who's sending this command is authorized to do, like if you're entering into any new building, you'll be given an ID to enter. So that's the way it will check whether this is an authorized person who is performing this task. Authentication. Authentication in the sense it will be doing whether they have the specific permissions to complete this task, and admission only when everything is satisfied it will perform the action. So scheduler is very intelligent. It is like it continuously scans any new pods that I've assigned, and it will keep the note of all the CPU and memory of all the other pods which are available in the worker node. And controller manager is used when you want to set a control loop, like it keeps a track of the cluster's state, and it keeps telling, like for example, if you want your Kubernetes to run this cluster of 5 nodes in your system, so control manager will keep checking it, and it will keep seeing that if there is 5 nodes available, if there are 5 nodes available in the Kubernetes cluster. If not, it will send a call to the API saying that hey, there's 2 nodes less than what I've asked, so please run those nodes again. So API will in turn call the scheduler to see which node is available and which node can run and make the get back to the same status of 5 nodes to be running. Like this is called as a reconciliation loop, like where the control manager keeps checking it and keeps communicating with the API server. etcd is like it is used to store the system's key value pair. Like if scheduler has selected a worker node, all the details regarding that will be stored in your etcd. It's like a central database of all the cluster details will be stored. And CCM is, it's not an what to say, it's not one which runs in everything. Like when you're using any cloud, then you'll be using CCM, like if you want to run any load balancers, and if you have cloud has a provision for that, you can link using this CCM. So these are some of the control plane components. Let's go for the worker node components. So worker node component is like it will have a set of things which will every node will have a set of components which will be similar across all the nodes. Like I've shown in the picture, like there is a kubelet in both the nodes, and kubeproxy and containerd, and each node will be having CRI, CNI, CSI. So I'll be explaining what are those. So let's start from what is kubelet. It's kubelet is like one which runs in every node in the Kubernetes, and it checks to see if the container pods are active and they are in a good condition, and it is ready to be used. And kubeproxy maintains like whole network rules of the node, and it will allow the communication from the pods to the inside or outside of your cluster. So all those communications like IP tables, IPVs, everything are being stored in the kubeproxy. And pod is like a fundamental scheduling component, like where it will have each pod will have a unique IP address, and it will have some storage volumes, and it will have the information like how the container should run. And containerd is like a runtime, like it is responsible for Kubernetes container runtimes. Like when a pod is being scheduled, like kubelet keeps always pinging API server, asking, hey API server, do you have anything for me to run? And it keeps pinging it. So when API servers gets a request, like as I showed in the previous slide, like kubectl run nginx, so then API server will tell, okay kubelet, you can run this information, like run this image in this node. So then kubelet will send this information to containerd. So containerd will run will take like a CRI, like which is a container runtime interface, which is used to fetch the image like nginx image, and then CNI, which is the container network interface, which is used to build the network, and CSI, which is the container storage interface, like which will build the storage for this image. So all those work are being done by containerd. So this is a complete architecture of Kubernetes. Like when a user sends a request, it will come to the control plane, where it will have API server, scheduler, control manager, and etcd. And the scheduler will have information as to which pod is having how much of capacity or CPU, and then it will schedule it according to that. And our applications will be running in containers inside a pod like this. So let us learn a little introduction about YAML, like what is YAML. It's a widely used cloud native language. It's a human readable one, very easy to learn. And YAML means it's ain't another markup language. And the only thing which matters more here is the indentation. And as you can see here, there is a space which is left like a tab. That is very important. And most of the YAML is consisting of key value pairs, where you will have a key and a value which will be associated to it. And the one metadata which you can see here is like an object, and all these things are attributes of this metadata. That means it is an attribute of this object. And when you want to specify a list in a YAML, you put a dash like this, and all the items which are below it are list items. And if you want to put a very large string inside YAML, that is when you use a pipe symbol. And this is a certificate, like I am just showing you, like I've put a screenshot like how you can put a very big string inside YAML. And if you want to store any environment variables, you need to use the double quotes, and you have to put the dollar symbol for it. And if you have different objects, like I've shown you here, this is one object and metadata. So if you have different objects here, so you'll be having you need to put 3 dashes so that it differentiates between the objects. So these are some of the basics YAML which you need to learn when you're trying out Kubernetes. And most of you will be thinking like, how can I start with Kubernetes? Like, is it very tedious? What and all I need to install, and how can I start off with it? There are many resources available, and you can try out Kubernetes even without installing into your systems, which I'll be showing a demo. And if you want to run it locally on your system, you can install Minikube, and it will use the resources of your system locally, and you can play around with the Kubernetes. And you can use kubeadmin, and there are many cloud providers like Azure, COG, Google, AWS, and you need to pay for the resources and the time you use them. And if you are a beginner and you want to try out, and there are different ways to try out, and there are two important websites which you can use, like Play with Kubernetes or Killer Coda. Today I'll be showing you like how you can try out using Killer Coda. So since you've learned how Kubernetes is used, and there are different ways to operate, and you need some other tools to take care of the cluster. So that's when these are some of the tools which are coming, like Lens, Monocol, or Kubescape, Teleport, which are helping us to operate with Kubernetes very easily. So I'll be giving a demo using Killer Coda. So this is a Killer Coda website, and you can go, after you log in, you can go for playgrounds. So you can select the latest one, Kubernetes 1.25. And you need to start, and it will create a cluster in the background, and even if it takes little time for you, like it will be creating things in the background. I have already kept it ready so that the demo can be shown. So let's run a few commands. So this is how it shows us, like if I just say kubectl get nodes, it shows us that there is a control plane and a node, worker node, which is already ready, and it will show like what is the age of it, and it will show the status. And we can say like So this will give the information regarding the pods, like I've already discussed you. There is a control plane, and it will have a scheduler and queue proxy and control manager and API server, and all this are regarding the network, which I already mentioned you, like CNI. So these are all the networking part of it, and this etcd, like which I already mentioned, and you can see the details of this nodes also. So this shows like which is control plane and which runs in a worker node. So as I told you, the proxy, scheduler, and as well as the etcd, API server, control manager, all this run on the control plane, and the ones which are running on the worker node are also being shown, like the networking part of the cluster is being run on the node side. And I can show a demo of creating a pod. So this will show that a pod nginx has been created and it's in a running state. So this is how you can use the killer code and uh, get some way of knowing what are the different commands which you are going to use and how will it be done. And you can also use like a dry run to see how the YAML file will be looking. I'll just show you that. And you can also see the namespaces, like what are the namespaces available here. So there is a default namespace, public namespace, and a lease namespace and a system namespace. So all these things can be checked in your killer coda. So it is a different playground which you can use it and learn Kubernetes. And that's it. And thank you for OSCONF team for giving me this opportunity to share my knowledge about Kubernetes. And hope this inspire you people and you try Kubernetes and try out variety of things which can be done and how it will help you solve your problems. Thank you.
Okay, so we have two of the speakers today for our next talk. The first one is Aditya Krishna. He is an associate software engineer at Red Hat. He is an active contributor for Layer 5 project, Meshmate, and maintainer for Mishri, a CNCF sandbox project. He also contributed to open source projects like Brave Browser, Mattermost, and few others. And now, along with him, we have his co-speaker Karthik Ravishankar. He is a software developer working on enterprise security platform at Morgan Stanley. Today, both of them will be speaking about Red Hat OpenShift extension for Docker Desktop. Here you go.
So, good morning, good afternoon, good evening from wherever you're watching us. So, welcome to our talk on Red Hat OpenShift meets Docker extensions. So, talking about us, who are going to be your host for the day. So, my name is Karthik, and I'm a software developer at Morgan Stanley, and I'm going to be speaking alongside Aditya. Aditya is an associate software engineer at Red Hat. So you can follow us on Twitter and LinkedIn, where we are most active. So yeah, let's get started. So the agenda for the day looks something like this. So firstly, we're going to give a short introduction on Docker and Kubernetes, and then followed by an introduction to Red Hat OpenShift. Then we'll be speaking about Docker and Docker extensions and Docker desktop as well. And we're going to be ending this talk with a demo. So yeah, that's pretty much on what we have for the agenda today. So let's get started. So Docker, like you know, is an open platform basically for developing, shipping, and running your application. So basically Docker, what it does is it basically separates out the applications that you have with the infrastructure. So basically it's shortening your headache, and basically you can focus on the software more, and you can deliver software quickly. So with Docker, basically what you can do is you can manage your infrastructure in the same way as you manage your applications. So yeah, I mean, that's pretty much what Docker is all about. But yeah, I mean, if I were to basically describe Docker in the way Docker does it by itself, basically Docker is a tool that takes away all your repetitive mundane configuration tasks, and it's basically used throughout the software development lifecycle, and it's used for fast, easy, and portable application development, both for desktop and cloud. So yeah, that's pretty much about what I wanted to talk about Docker. Similarly, so yeah, Kubernetes is an open source container orchestration system. So it's a initially it was a project which was designed by Google, and it's now maintained by the Cloud Native Computing Foundation, the CNCF Foundation. So yeah, Kubernetes is basically a system that's used for automating app development, scaling, and management. So yeah, more about it later in the slides. So let's move to the next slide. So a short quote. Kubernetes orchestration basically allows you to build application services that span multiple containers, schedule those containers across a cluster, scale those containers, and manage the health of those containers over time. So with Kubernetes, you can take real steps towards better IT security. So this is what Red Hat has to say about Kubernetes. Moving forward, so moving to the heart of our talk, it's perfect time to talk about Red Hat OpenShift. So what Red Hat OpenShift is, that it's a Kubernetes container platform basically. It's built for an open hybrid cloud strategy, which is basically battle tested, as Red Hat calls it, and it's also totally enterprise ready, which is one important reason why a lot of enterprises choose Red Hat OpenShift. So Red Hat with OpenShift basically provides a consistent app platform, which is basically used to manage hybrid and multi-cloud along with edge deployments. Yeah, so moving forward, I think it's time to talk about Docker, Docker's other offerings, which is Docker Desktop, and inside of Docker Desktop we have Docker extensions. So yeah, I'll be talking about these two in the upcoming slides. So Docker Desktop is basically a landmark for Docker. So anyone who's new to Docker can basically get started with Docker Desktop, I would say, and including me, when I was very new to Docker, I started off with Docker Desktop because you can get started in no time, whilst sticking to all the best practices of Docker. So yeah, Docker Desktop basically helps you to quickly and safely evaluate software, so that you can start secure and basically push with confidence. So I mean, nowadays, developers like you and me, right, we are looking always for a simple way of deploying applications on Kubernetes. So I mean, we also don't want to forget the best practices while doing our application, our deployments. So this is where Docker Desktop will be a perfect fit for our needs, where you can also follow best practices whilst already bringing in all the security that Docker Desktop has on offer. So now that we know what Docker Desktop is, I think it's a perfect time to introduce what Docker extensions are. So Docker extensions were very recently announced, and I would say it's one of the um, you know industry leading solutions that Docker has right now. So Docker Desktop has right now. So it makes things so easy for you, which you're going to see later in the demo, which Aditya is going to be doing. So with the OpenShift, of course, the OpenShift extensions that is available on the Docker Desktop Marketplace. So yeah, Docker Desktop is basically used to extend Docker Desktop's capabilities by using different integrations of developer tools. So basically, organizations come and make it easy for their developers to get started. So yeah, so Docker Desktop extension, Docker Desktop's extensions, basically they optimize your application workflows, and by by connecting to many pre-built developer tools for debugging, testing, networking, security, etc. So I mean, Docker Desktop, as Docker calls Docker Desktop, is basically the fastest way to containerize your applications, and with Docker extensions coming into picture, so Docker Desktop and Docker extensions go hand in hand extremely well. So I think it's the perfect time to stop my introduction and move forward with the demo, where you'll be seeing how magically Docker Desktop and Docker extensions will basically help you do very powerful stuff, which otherwise would take you a lot of time. So at this point, for the demo, I would like to call Aditya, who's going to be here talking about how the Red Hat OpenShift extension can be used on Docker Desktop very easily. So yeah, give it up for Aditya. That's it from my end. Thank you.
Thank you, Karthik, for the wonderful insights regarding introduction to Docker, Docker extensions, Kubernetes, and of course, Red Hat's OpenShift. So, hello everyone. Let's get started with Docker extensions and how you can use Red Hat's OpenShift Docker extension to deploy your Docker images directly to OpenShift. So, you might be familiar with this specific UI. So, if you open Docker Desktop, you need to go to your settings, that's here, and then you need to go to your extensions tab, and then you have to click on enable Docker extensions. Once that's done, you need to apply and restart the Docker Desktop application. And as I've already enabled, so let me just skip that step. And once you restarted your Docker Desktop, you'll be greeted with this specific section on the left side. It will say extensions, which is in beta mode right now. So now let's go to the extensions marketplace. There are many extensions here which can help you to do many stuff like lens, Docker's disk usage one, which will help you to view disk space used by Docker and reclaim the space and all. But now let's focus on Red Hat's OpenShift one. So I'll click on install. You can view the details directly here, and as the extension image is not available locally, it will be pulling from the Docker Hub itself. This process is going to take a couple of minutes for the installation thing to happen and all. So yeah. So now that the Red Hat OpenShift Docker extension has been installed, you will be greeted with a successful toast notification saying that the extension has been installed successfully, and you'll see the specific button as well. You can click that to open the extension module or section of the Docker desktop, or you can just go here and click this one. Now you will be able to see this specific UI, and if you are new to Docker desktop and you are deploying for the first time on OpenShift, your context will mostly be in Docker desktop section itself. Now let's see how you can add your own context, or probably if you want to try Red Hat's OpenShift, you can how you can do that basically. So now what I'm going to do is I'm going to go to Google Chrome, and I'm going to click on OpenShift.io. You will be greeted with this specific site, and you can get a 30-day free access to the shared OpenShift and Kubernetes cluster. For that, you can start your sandbox for free by clicking here. And you can, if you don't have a Red Hat account, you can register for the same. You need to fill this small form and confirm your email with a verification code and all. Once you are done with that, you will basically be logged into the OpenShift trial thing. So as I'm already done, I'll just go to that specific area, and once you are successfully logged in, you'll see this specific dialog box. So for now, I'll just click on start using your sandbox. And once you click on that button, you will be asked to log in, and then you will be directed to this screen. So let's see how you can basically connect the OpenShift console with your Docker desktop or Docker desktop's OpenShift extension. So I'll click on the menu button here and go to copy login command. So I'll be greeted with this login thing, and then I will click on Dev Sandbox. And then I'll have to click on the display token to show my OpenShift login token. And this is the command which you are going to use basically. So let me just copy that. So once that is done, you can go here and you can click on change context. And if you created and followed these steps correctly, you can log into your OpenShift cluster by just going here and pasting the login ID here, and everything will be auto-filled. And then once that is done, you can click on login. So you can see this successful toast saying that I have logged into the OpenShift console. So now what I'm going to do is I'll just select a basic image for me to deploy on Red Hat OpenShift. So for that, I'm gonna probably use the MySQL one itself. So once I selected the image, you can select multiple images. Like let's say if you want to deploy Kiali, or let's say Meshery, or any other application for that matter. Even you can deploy your front end applications as well, or back end which is written in Go or any other languages for that matter. So now once that is done, I'll just click on deploy. So before I click on deploy, there are multiple options which you can choose. You can directly push to Docker Hub, but for that you will be needed to sign in with Docker Hub, and then your Docker desktop should be connected to the Docker Hub itself. And then you have another option known as push to OpenShift and deploy. For now, I'm gonna choose the basic deploy one, and then I'm gonna click on deploy. You can see all of your deploying logs here, and once that is done, you'll basically see this successful toast notification saying that the application has been deployed successfully. So now what I'm going to do is, you can see these commands OC status, which is used to determine the pod status and what and all is running, and if your application is deployed or not. So let me just go to the OpenShift console here, and then on the console you can see this terminal icon, which I'm going to click right now, and this will connect to your OpenShift command line. So yeah, let me just type OC status. You can see the applications which you deployed in your specific project and many more. So for now, this is about the OpenShift Docker extension. Let me show you what the OpenShift console can help you with. So for that, this is the screen which you will be greeted with. You can choose to be a developer or an administrator as well, if you are using the trial account. And then there are multiple samples which you can play around with, or if you want to start using Helm charts, you can do that one as well. So let me just go to one quick sample here. There are multiple samples here, like .NET 1, basic Hello World application using Go, a basic Hello World application using Node.js, Python, Spring Boot, and many more. As it's a cloud native thing and related to DevOps and all, let me go with basic Go. So this is the and you along with this, you basically can deploy from a GitHub URL as well, or a Git repo URL as well. So I'm going to deploy the Hello World Go application. I'm just going to name it as Go OSCONF basic. So let me just create that. You will see this successful toast notification saying that the resource has been added and deployment has been created successfully. And if you go to this specific screen, you will see on the left side, you need to go to the topology one, and you will be greeted with this specific UI where you can see your applications running. There's like one previous application which I deployed, that is Adi Go test. There's like the Java Spring Boot classic one. There's MySQL, which I recently deployed using the OpenShift Docker extension. So specifically, you might have a question now. What is the topology view? The topology view in developer perspective of the web console provides a visual representation of all the applications within your project. So I can say it's something like the list would be a pretty basic view. If you want to see the apps in a more GUI friendly manner, you can use the topology view itself. So yeah, that's about it, I guess, from my end. And then I'll leave you a couple of other options to explore on your own, and then learn about the Red Hat's OpenShift platform, the console, and all. So yeah, thank you so much everyone for listening to us, and then I hope you guys have a great rest of your day. Thank you.
Well, hope you guys are having a great time here at OSCONF. We have our next speaker, Rohit Kumare. He is a developer advocate at Solo.io and a community evangelist. He has been participating in various conferences as speaker and panelist. Today, he is here to talk about an interesting topic titled Service Mesh but without the sidecar. Over to you, Rohit.
Yeah, so welcome to OSCONF 2022, and I'm here to present some things related to HTO ambient mesh and HTO service mesh, and more about the sidecars. So, what is a sidecars? If you know, like sidecar is like if you have seen some movies and series, and on the road there is one bike or like some type of a motorcycle where there is sidecar attached to it. So we are going to read out that sidecar today. So how to do that in the HTO world? So it is already done. So we will talk about the same, and what actually it is. So why it is matter, and also we will discuss it today. So I am Roy Gumre, and I'm developer advocate at Solo.io. To know more about me, let's check it out. So I'm anime fan. Ignore that. So another thing is I'm founder of communities like Keep Up, DevOps community, Developer Relations community, and Keep Up is like one of the community where like I help the students to get the trainings and internships and jobs opportunity. DevOps is like more of the DevOps. You can talk about the DevOps awareness and all. So developer relations is like I'm currently working as a developer advocate. It is a developer kind of thing. So yeah, if you have any doubts related to developer relations, DevOps, and you want to work at like remote work kind of a thing, reach out to me. Many people do the same. Another thing is there are various handles given like Twitter, LinkedIn, portfolio. You can reach out to Twitter, LinkedIn anytime if you want to check the blogs and my talks and many other things related to myself. You can go and find it on my portfolio. So let's start with our today's HTML invest. So I guess many of you already know like what is service mesh. So service mesh is kind of a thing. Why to directly start on the service mesh, right? So before service mesh, there was like we are like connecting the services. There is one service, then there is a service link. To connect them, send the request and something. We were using traditional methods like microservices and various things. So it was really hard to add the resources and do the do the challenges and stuff on these things. So it was really tough. So that's why before like utilizing this Istio, we were like having these were many challenges and add-ons problems. So that's why service mesh was introduced. And in service mesh, what happens? There is like you have the operation code, and you have the thing, like you have the actual system, right? So but you can't add the resources, and you can't add the things like add-ons to your application, like that is in simple words it is like business logic. So if you want to sell your product and something, so it is like application. you have the application ready, but in future if you want to add something, and currently if you want to add something in your system application, so it is really big challenge in the before the service meshes. But after the service mesh was launched, what happened? Service mesh introduced the parallel system between the same parallel between the applications, which is like operational code, and another is business logic. So business logic is like now you can easily apply, so it is separately added, so you can easily apply the resources, you can easily apply the security, you can use the like routing purpose policies you can attach, different things you can do by this newly introduced service mesh at that time. So this is like if you have some application, right? So in application, what you can do if you have some product page, which is like food selling product page, so that page has a website ready, and anyone can buy and something, they can send the request and all. But if someone try to access, then security breakthrough can happen also, like outer parties can access to them. Another thing is if you want to boot it to various websites, like various domains and IPs, so that's why you need something to add that, right? So it is like entire distributed services, you can cluster it and you can create some web out of it, so that is known as the service mesh. So yeah, let's discuss further. So what are the platform goals with the service mesh, right? So that is much important thing. So here you can see there is like application level routing, observability, resiliency, zero trust security. So what are these things, right? So you don't know, you know. But yeah, Rohit is here, so he will tell everything about it. So application level routing. So yeah, offload application level traffic routing and offload application level filtering and transmission. What are these for? So service mesh provides you. So there is L7 and L4 proxies and various layer proxies. So there are various layers, right? So if there is various layers, right? So what are these layers? So in OSN model, if you remember in your computer networking subject, there was OSN layers. So there is a layer for transport layer and layer 7 for application layer. So if you want to give the services routing and like you want to add on something on that application level, like you want to edit the policies and you want to filter out some application like this can access, this can not access. So that things you need to do by this application level routing. So service mesh, HTO service mesh provides the same, and observability, anchor point for traffic capture. What is this? So if you have given that anything like application, it is production ready and something, but in future you want to check like how many people are there connecting these things, and how the our application is going and everything. So how you can do these things, right? So that for that you need something, right? So Istio provides the observability in the form of connections through various systems, they various other add-ons like Prometheus, Grafana, ERE, whatever you can add, and there are various open source tools are there which you can connect. So it helps you to check the logs and various observability indications you can do to check the you can capture the logs, you can capture the traffic, and yeah, you can get benefited from the same. So resiliency, so it is like if there is any routing and all going on, so you can enable it easily. You can if there is any downtime or something, you can easily like failover you can apply, and there is like various things you can do on the same. So zero trust security, that is must needed, like like you want some communication between the microservices, so that time it should be secure, right? So for that you you need to assign some certificates and install to your proxies to get these things done. So Istio service mesh and that platform goes. So yeah, to enforce them you require the same. So how Istio works today? So like there are data plane and there is a control plane. So what actually are there? So as you can see in this diagram, so there is service A, there is a service B, and there is a Istio control plane. So what actually is the service A here? Service A is like box and there is some envoy proxy. So what actually is this envoy proxy, right? So yeah, so as you can see, this is data plane, and in data, why it is data plane kind of a thing. So every app services is assigned some envoy proxy to it. So envoy proxy is something which we discussed at start. Sidecar. So sidecar, it is like everything you have to do to your services. So everything you you want to add some security, you want to add some traffic or something. So Istio will directly contact the envoy proxy, and envoy proxy do the same. So every application has the same. So there are, you will see like when it is deployed, there will be 2 ports or something. So envoy is like sidecar of the application, and all L4 and L7 like the policy traffic goes through only the sidecar proxy. So yeah, as you can see, like your control plane is distributing some certificates to them to like secure and things, and in like it easily shows the metrics and everything to check the logs and all to the Istio control plane. So another thing is control plane. So control plane is like your main master of your so as you know, in the Kubernetes there is a master node and various things, right? So here it is like control plane of the Istio is this control plane is the master of the thing. So he is the only one who keeps the track of the service mesh, and it will only it has only permission to deploy and everything. So proxies, filters, policies, everything to them. So control plane is separate from proxy data plane. So what happened if there is some security challenge, like if someone from the outside gets into this thing and it tries to access, so it will be not easily, but it has a possibility to get breakable, and our services get challenged. So how to make it secure? So that is main problem, right? So Istio is like lets you program application where traffic management and incredible observability and robust security capabilities into your network. So as I discussed everything, so it is written in the challenging words. So yeah, Istio sidecar model. So as you can see, in Istio sidecar model today, what is happening? It is having the application, it has the resources attached to it, but it is attached to the envoy only. So this envoy proxy and its application entire in the nodes, there will be separate kind of pods and services attached. So services will have one pod for the application and resources and envoy. So the node is having the same. So every node will have the separate two pods containing the same. So it is, one is the sidecar and one is your application and things you want. So yeah, potential challenges with the sidecar processing. So overhead cost, like you have the different envoy proxies for every application. Operational complexity. So operational complexity is like really challenging. Like if you want to like access something, you want to send some resources or something, so it goes to the envoy proxy, right? So it is really complicated if you want something on the application 7 out of these every nodes. So performance challenges, performance is like it will reduce, it was like it has some time gap, right? Because it contacts the L4, then L4 to L7, and then to your second application. So application 1 to application 2 like get request and put request gets like getting the request resources is really challenging in the simple words. So yeah, here it is your sample Istio book info page, which I was talking about. As you can see, this is product page, details, ratings, reviews, and various things are there. But as you have noticed, there is like 2/2, 2/2, 2/2. So what is this? This is like one is your application. I'm just giving you a brief. So one is your application kind of a thing, that code, and another is your envoy proxy. So as you can see, it is increasing your cost by having some separate entire pods for you. So it will increase the time also to install that things. So yeah, so there are various challenges in your Istio service mesh. Operational complexity, as I told, like there is a application, it has the resources and it has the envoy proxy, but if you want to get something out of it, then it is really big challenge, like it is really complex structure, and there is, as you can see, I have added some cartoon for you. Challenges everywhere. So this happens, like there are various applications, various open source tools, and there are various challenges, but how to get out of it. So that's why we are here and you are here. So application mesh aware. So as you have seen, like there is one job you have to do, but if you want to do that job, then it is really hard to tell your resources to get that done. So mesh awareness is there. So another thing is latency. As I told, like application is sending to envoy proxy to another envoy proxy, and then envoy proxy is sending that request to application 2. So what happening is here, it is like it created like 2 millisecond of contact. So it is like 2 milliseconds, but when you are doing the big system or kind of things, like there are thousands of pods running and applications are running, that time it is really hard to, it is like big number there. So as you have like everyone is thinking the same, like yeah, sidecar is the big issue, but it is not an issue. It is nice, like you have the separate proxy here to contact and something, like it is nice, but there should be something like which can pretty beneficial, which is sidecarless kind of a thing. So we can check also, like does it easily decrease the things, or it is like system is smooth or not, applications will run same, and it will reduce our downtime or not. So for that we need something, right? So at this step so every companies are like trying to reduce the cost, and cost optimization is a big issue in every companies and startups. So as there is separate envoy to every pods, every pod is the same, like separate proxy, and also it is like big cost budget you are installing here. So that's why, to reduce these issues, I guess I should start with this. So yeah, introducing Istio Ambient Mesh, new open source contribution to the Istio project that defines a new sidecarless data plane. So it is different sidecarless data plane in Istio. You can easily see that. So Solo and Google are the lead contributors to the Istio Ambient Mesh, and as you know, like Istio has been added to the CNCF project today as an incubating project. So today, so it's really nice, and you can be one of the contributor to this project if you want, and in future your name will come after this solo Google and your name. So to get these things down, as it is new project, it is not production ready yet. So it will be production ready around like next year start or something. So till that you should contribute, and I guess your name will get reflected, and it will help you to get the various remote jobs kind of thing. So yeah, it reduces your cost reduction, it reduces your it increases your performance, it reduces your challenges, simplifies your operations. So let's see how the sidecar list is beneficial to our budget and our wallet and various things. So yeah, what is the model, right? So as you see, like HTML embedment is there, and there is only one layer 4 is there. So it is connected to the Z tunnel. So what is Z tunnel? We will get down to it. And another thing is, if you want to access the L7 policies, then there is L7 policies at the bottom. So it will contact directly to L4 and L7, and then direct application to. So it is like, it doesn't have the envoy proxy or something, like it doesn't have any proxy at the side. So there is no sidecar. It will directly contact the application to, but just your request will go to some kind of a Z tunnel out of it. So your time and time get reduced, your cost get reduced. You don't need to add separate sidecars for same. So same for the L7. So as you see, I think it is the biggest advantage of the H2 embed, which is like you don't have the separate sidecar, and directly your cost is getting reduced. So cost optimization done. You have saved the dollars of budget for your your project. So how it reduces the cost, as we seeing here, is to a sidecar data plane. It has the one pod, and one pod has the one proxy attached to it. So P is your pod, and there is proxy attached to it. And sorry for that. So P is your proxy, and then there is a pod, and a pod is like your container or something. So it's like on the left, and on the right there is the ambient mesh data plane, which has entire node with the different ports, and there is one proxy, which is like in entire node. If you want to communicate through any ports, through separate ports, it will go through one proxy only. So you don't need to have anything like different proxies for it, and your cost is directly getting reduced here. So what is the embed mesh means for your wallet, as we discussed. So you can refer to this blog written by one of our colleagues in solo.io. So it shows directly like total CPU is reduced to direct 0.3 when it was like 3.1 in the sidecar, and is your virtual CPUs, and another thing is the ambient L4 plus L7, then there is a 0.6. So as you can see, 3.4 into 0.6, this is like a big number gap. So similarly, total memory is reduced to 384 in the L4. So I guess this is like big things we are talking about here. So yeah, challenging and exciting thing. So 768 MB here, and the L4 plus L7. So what actually is this? If you see, like if you are running something on your application on your virtual machine, so there you launch the CPUs, but many times some application doesn't run, and it needs you to increase your sizes, instance types, virtual machine types. It increases your wallet price, and you need to pay higher. So that's why this H2 embed mesh will reduce your lot of budget kind of a thing, and it will really benefit your wallet, I guess. So yeah, another advantage is performance gap. As you can see, L4 has the 1 millisecond kind of a transfer to one-on-one, but embed mesh has the same. But as you see in the sidecar L7, there is 4 millisecond contact, but in L7 it is just the 3 millisecond. So really big number it is when you are like doing 1,000 running pods and 1,000 running nodes or something. So that's why I guess this is really beneficial, and I really used it, and I found it really nice. So various things here it is like it reduces the cost, simplify the application, improve performance. But how? So reduce cost is done by the proxy per node, as I told. There is a multi-tenant proxy, which is like you can do anything between the pods containers by only one proxy, and it is lightweight at the L4 proxy, and the implementation is U proxy, which is I guess it is a waypoint proxy. I don't remember, but yeah, it is simplifying operations. So mesh is transparent to applications. So decouple proxy from applications. So what actually is I'm just confusing, I guess, yourself. So what happening? So your mesh is transparent to applications. So whenever you are like contacting between the things, application directly accesses that mesh, and it can see everything going inside. So previously it was like there is happening in the proxy, so that's why it was not accessible easily. So yeah, whenever you are adding new applications, if you have so there is a book info, but if you want to add new reviews pages, and if you want to add new application to it, like food ordering application, if you want to add into the book info, so then it is really simple. It will not restart your system or anything. It will just add it, and you don't need to restart or something. So application updates will be easily given to the new releases. So yeah, that's what is there, and yeah, in future that can be eBPF be added. So how we'll talk about it, and it default in default it gives you the zero trust security. This is one of the beneficial thing, like you can easily see the certificates also. So what's next? As we told here, so L4 matrix, and there is a mutual TLS connection going on within the application, so which is really secure, and you can see the matrix easily. So in future we can add the eBPF. So eBPF will really increase the time and performance for your services, and connection will be really smoother. So there is a various additional resources here, which is some are there on my tweets also. You can check there. Some are here, which is blogs, demo videos, so how we actually work and all. So we have this hands-on certification training also, Solo Academy, which is fundamentals for ambient mesh. It will give you entire brief about how these things work. I guess I will show you some kind of blurb for it, like how it is actually that training is there. But if you want the certification, you have to take that directly on that links. I will provide the slide to you. So yeah, let's move with our demo. So as you can see, we need to deploy a client cluster, So yeah, here it is. So yeah, these are the steps to deploy the client cluster, as you know already. So I will just run fastly here. Actually, this is virtual environment, so it is like everything is there, environment is there. So you just need to create the cluster, as I have shown the steps here. So whenever you are creating the client cluster, it is given there like whenever you face the challenges, like there is a commands like if you run the check.sh script immediately after your deploy.sh, so deploy.sh is here, and if you run this check sh directly, then you will see some JSON path we are not seeing here. So yeah, so you can wait for a few seconds and you can try again. So it is not a big problem. So we are installing here the HTOCTL, which is provided for like ambient. So newest version is there, and yeah, here you can see like it has the ambient update already. So you can add here, and it is downloaded. So let's extract that ambient HTOCTL. So once that is done, HTOCTL is there, as you can see here. So ambient profile is designed to help you get started with ambient easily. So install HTOCTL with the ambient profile on your Kubernetes cluster, I would recommend. So how, just we have to set the profile. So just you can with the set profile the ambient, and your ambient is directly there. So yeah, it is here. So it is installing, as you can see. By default it is giving you the HTO core, HTOD installed, CNI installed. So CNI is the one which will be big thing, calculate contact with everything. So it will be the one to contact with the ztunnel, the proxies and all. So you should learn more about the CNIs. So it is the biggest thing to attach the traffic routing, securities and all. So after running the about command, as you know, like we have here, so as I told, like by default it provides HTTP, HTTP and all. CNI is responsible for detecting the application ports as like there, and configuring the traffic detections return. So as the like you can check the ports, but it is in the HTO system namespace. So we need to mention there is a slash n and -n and HTO system. So as we see, like yeah, there is 1/1, 1/1. So we didn't need to anything like we don't have any 2/2 now. So we have only 1/1. So there is no extra port which is your proxy or something. It is running, and you can it reduces really, as we talk, like cost and everything. So you don't have the sidecar now. So you will notice the following ports. Yeah, we have that ports. Let's deploy one sample web API, fake services. So it has the sample directly in HTTP ambient. So we have provided here, but ambient also provide the samples as a book info or something. So you can directly get that application. As you can see, like there is already our everything is running, right? Our HTTP is running, ztunnel is running, ingressway is running. Now we will not restart it and directly install our fake services. So how cool is that, right? So see here, unchange. So I was here, yeah, it is directly it is there in the files. So it is showing here. So everything is there. We just need to deploy the sample application we did. So let's check our get ports. See here, not sleep is there. So not sleep we will use to like don't communicate with it is just a sleep, and not sleep is just to call thing to communicate our applications. So I am using that, and yeah, there is web API history and all. So this will be our what we say, to sample application to call we will use to sleep we are using to call our web API. Let's see what it gives us. So it is showing like HTTP is there, recommendation page is there, hello from recommendations, hello from purchase history. Yeah, our application is running. So as you can see, it is doing the simple application connections between the services, and as we have done that, expose our web API. So our traffic for the inbound traffic is for the mesh is controlled with the HTTP ingress gateway. If you know ingress gateway, so it is like something to do the exposing and everything about your services. So we are doing the same, and let's expose our kubectl using kubectl. So we have exposed here, as you can see, virtual services gateways. let's export here our files that values. Once that is done, let's call again. So we will be able to access our access our web API by using the Istio Ingress gateway. So host header specified, we have given that directly. So as you can see, it is giving us the web API and everything. And we did using this using our Istio Ingress gateway, and we are using this Istio IO as like our host. So it is accessing through our host. How cool is that? So for a small demo, I will show you how you can add the services to this ambient. So as we did everything already, just we need to add our services. So here, as they are saying, like there is a data plane available, another data plane is available. So we can directly add an ambient directly there, don't need to restart or something. So namespace is adding, we have added the default to like ambient. So done. We don't need to restart or something, and it is set. So as you can see, this logs everything with the ambient label. Let me check. Yeah, so our ambient mesh is enabled, and it will be easier to show here only. So CNI daemon set each node constantly watches for pods that are running in namespaces with the label. It is directly there. Whenever pod with matching namespace label is detected, CNI, it is easy to read, you can go through. So what actually is happening here? So our so what is actually happening here? So as you can see, so it is showing here IP set is done. Then it is just it is just giving you the overall picture. I guess I lost it. No, logs are there. So it is adding the route, and the CNI is accessing everything, and you can easily see like IPs are set, and now you can route through them. So let's do one sample thing. So what will happen here? So sleep will be used to call like ztunnel is the one to the connections and all. So see here, so to access the client, so if our client wants to access the web API, so client is here sleep, and not sleep will be the one who will not able to access, because we will not provide him the access. So this is like mutual TLS connection and secure connection. So how it will done? So as you have seen, like there is a ztunnel. Ztunnel will do everything for us. So we will know the ztunnel. For the client ztunnel will establish the mutual TLS connection using the client key certificate. We can easily see. So how that certificate looks and everything. Let's see here. So you see here, yeah, we did the certificate, means like we generated some traffic, so we can easily see in them logs. So as traffic is done, so as you can see, there is outbound capture tunnel, a listener and object tunnel, outbound tunnel is there. So it is using some client address. Similarly here it is everything is easily available, and you can capture listeners and all. So here, if you have noticed, so there is a captured outbound. What is a captured outbound here? Right, everywhere it is there. So it is your no waypoint proxy in the log. So a ztunnel knows like whether there is some waypoint proxy or not in the server side. So we will explain this soon when we introduce some policies. But it is not in this demo, so you will have to do the training. So it is there in the demos which I have referred you the links. So go there and you can check. So depending on that, so what is happening, just do one sample test we can do here. So we will use that sleep to access, and not sleep will not have the access. So we are setting some policy, so denial policy for everything. So if you see there is a allow nothing policy is added, and you shouldn't be accessible to access the web API application anymore, as I told. So yeah, it rejected me, sorry for that. So let's create the different authorization policy which will only allow to access sleep. So as you can see here, principals is given here, and sleep is allowed to access the ingress gateway. So yeah, we are setting the authorization policy where API connected is web process is there. So as we did this already, let's access our web API. Yeah, we can access it now with the ingress gateway. So it's nice. But if you try to access to our unauthorized pod, it is not sleep, I guess. So it will not give us the access. So yeah, I guess it is nice. Like you have the application running and everything. Just you don't need to like restart everything, and you can set the security, and you can check the certificate also. So how to check and all. That is a different thing again. So we will not discuss it. You can check on the demos. So yeah, thank you for having me. It is really nice to have this much audience, and I guess you have the many doubts and you need to ask me and all. So yeah, DM me anytime, and you can let me know on my various handles. So I guess thank you from my side. Nice, it was nice audience and nice people.
Okay, so we are towards the end of today's session. Our next speaker is Vasil Varghese. He is an ex-Akamai, worked as a primary liaison of the data analytics platform. He co-founded co-it.io and delivered 13 plus advanced community cloud native courses. He's also corporate trainer and mentor, and today he's here to talk about how to set up a local environment for a developer with Docker, Scaffold, and kind. So here you go, Vasil.
Welcome all. Today we will talk about automating a local developer's workflow. It's actually kind of every developer dream to get a proper environment where they want to develop their application, and that environment has to look just like production. So if your company is using Kubernetes in production, the best local development environment that a developer can get their code to be tested would be a local Kubernetes cluster, and that is what many people prefer to do today. And basically a developer might want to make his code change, and as soon as he make the code change, he should be able to see a preview of the code change what he made, that comes directly from a local Kubernetes cluster. So in this talk we will have a discussion on how you can use different tools such as Scaffold, Docker, Kind, or Kubernetes. Kind is a local Kubernetes cluster, or it could be a managed Kubernetes cluster as well that the developer may be able to use to do their local development. So we will talk about how we can give such kind of a quick feedback to developers using a combination of these many tools. And then that's the agenda for today. How we can set up a local development environment, which is typically a developer laptop itself. That's where most developers do the development. So how we can create a local development workflow in a developer laptop. And then we will talk about a tool called Scaffold, right, which you are probably already aware of. If not, we will have a brief introduction about the tool, and then we will also talk about how we can combine Docker, Scaffold, and Kind together to get a proper local development workflow, most preferably within the developer laptop itself, right? And it would be a demo session. And about me, I'm the co-founder of Co-IT Technologies, and we build different cloud native training courses and stuff throughout our website. And this is my contact information. You can always reach out to me anytime through LinkedIn or through email. And with that, let's get started. So I just want to introduce about a tool, Scaffold, and what Scaffold does is it is a client side binary that can run on a developer laptop. And what this tool can do is it can watch for the code change that a developer do, and as the code gets changed on the developer laptop, Scaffold will take the changed code, build the code into a container image and tag it, and then it deploys a Kubernetes cluster with the latest tag that it just created. And immediately the developer can get to see a preview of the application that they have developed, and the entire workflow will run locally on the developer laptop. And that is the best part. So most developers prefer to make a code change and verify the code change before they commit to their source code repositories like Git. So most developers prefer that they first see a preview of their applications before they even put their changes into Git, right? So in such situations, a local development workflow is very much preferred by most developers, and most of the companies prefer this, moving everything towards the left side, having the developer ability to do most of the things themselves, right, without even before starting the continuous integration process, or even before the developer put their code into the Git, right? So let's talk about that. So I will start with a demo. This is a demo application that I have created just for today's demonstration. Basically what we have is a scaffold.yaml file, basically some instruction that we are giving to Scaffold. We are asking Scaffold to build a container image using of the application called symbol frontend, and on the left side what you see is the folder symbol frontend that consists of the application along with a Docker file, the typical Docker file that you currently have of your application that has the instructions to build this application into a container. And then I am mentioning in the scaffold.yaml file to build this container image and also push it to a registry and deploy my Kubernetes cluster with this latest image that Scaffold has just built. So I will just quickly show you a demo. Let's go ahead and take a look at my code. This is my code over here, and I have all right, I think this is not the one. I'll show you. Yeah, right here. What you see on my laptop is in my VS Code is basically a scaffold.yaml file that has a set of instructions to build my applications, which is nothing but the symbol frontend folder that consists of my application along with a Docker file which has the necessary instructions to build my application to a container image. It is a typical Docker file, not such of a big deal. And then it also has a K8s folder where I have two symbol deployment and service YAML file. And this manifest I can use to deploy this application to a Kubernetes cluster. And that's what Scaffold do, and that is exactly what I have asked my Scaffold to do. Build my project using the Docker file available on my application folder, and then deploy the applications to the Kubernetes cluster after the image have been built. And a Scaffold will automatically pick the correct tag before it deploy the application to the Kubernetes. It would make the necessary modification of the image before it applies the changes to the Kubernetes cluster. And also after deploying the Kubernetes cluster, I want to see a preview of my application by port forwarding the service to my laptop on a specific port number. So that's exactly what I had mentioned. So let's go ahead and run this command, and I go to my command line in my laptop, and the command what I am going to execute is scaffold dev. So what this command does is it would read my scaffold.yaml file and read all the instructions where I asked it to build the container image, then push it and also deploy my Kubernetes cluster. And right now I am currently using a Google Cloud Kubernetes cluster that I have created already in the Google Cloud. And then I already have kubectl installed on my laptop. So Scaffold internally uses kubectl apply command, whatever is necessary to deploy the applications to the Kubernetes cluster. And what I also have, I have Docker currently running on my laptop, and Scaffold is internally using Docker to build my application into a container image. So as I said, scaffold is just a binary that could run on your developer laptop, and then it would constantly deploy this application back to the Kubernetes cluster, and that's what it do. And looks like the deployment is ready, and it seems like I have some error while port forwarding the services, and let me figure out what is the problem. Default chat. Okay, I think I put my service name wrong. Let me sorry for that. The service name is quite and LB, that's the service name. So in the scaffold.yaml file I have a minor error. Let me try to fix that. Over here I'm going to change the service name to the service that I want to port forward. I'm going to change that, and then you can go back to the command line and see that. So basically I did not. All right, it's give me a second. Okay guys, sorry for that. The problem is solved. I had to correctly update the file name, the service name in my scaffold.yaml file, and then I rerun the scaffold dev command, and as you can see now, scaffold not only took my code, built the container image, stored the container image inside a registry, and deployed my Kubernetes cluster, and also it port forwarded the service to my local, which I can browse using my browser, right? I mean, that's exactly what I am going to do. I'm going to browse for this particular URL. And take a look. You can actually see a preview of the application that you have just developed. So this sounds awesome, right? A developer is making some code change, and then scaffold take his code, build the container image, and immediately push it to the registry, and deploying a Kubernetes cluster and giving a URL to your developer to preview the application what they have just changed. And yes, as a developer, that's what I keep on doing. I'm going to make some code change again, right? So assume your developer is going to make more code changes. For example, right now the heading of my website says type your message. I'm going to change the text, right? And for that, your developer has to make some change in the source code. So what I'll do is I'll just go to the source code and make some minor change in the app.js. This is a React project, and I'm going to change the message from type in my message to something else. For example, this is an awesome workflow, right? And that's exactly what I'm doing. I just made some code change, and let's see what scaffold did, right? So remember, you already executed the scaffold dev command, and what scaffold is currently doing on my laptop, it is waiting for any code change that I am doing in this specific folder. And as soon as it scaffold detected that I saved this particular file or any source code, scaffold will start rebuilding my container image, and then again it will deploy the latest tag into my Kubernetes cluster, and thus I would get a preview of the change what I did. So let's go ahead and take a look at the command line output where I was already running the scaffold command. You can see scaffold automatically detected that scaffold is watching the changes, and scaffold detected that I made some code change, and now scaffold is building a new container image, right? Now it is the Docker build that is going on, and immediately it would again push the container image to the registry, and then again give me the latest preview of the application very soon. And it can hardly take 1 to 2 minutes, depending on the time how much you take to do the building. Most of the time with proper Docker caching, you can actually reduce the time to build into few minutes, 1 or 2 minutes, or maybe if not seconds, right? So it is possible today. So the idea here is that every time a code change is made on the developer laptop, Scaffold detects that and Scaffold immediately make the respective changes to your Kubernetes cluster, giving you the latest preview of your application. Great. That's great. So that's a quick introduction about Scaffold and how it can automate the workflow of on a developer laptop. And I used a Google Cloud cluster today to deploy the applications, but it could be any cluster that your kubectl is currently pointed at. For example, if you are a developer and if your laptop can run a Kubernetes cluster such as K3D or Kind, that is the best solution, right? And for that, developer would need efficient laptops, right? Probably you need enough CPU and memory to test your application, and if that is the case, go ahead and install K3D, Kind, Minikube, or whatever your favorite Kubernetes cluster is on your local, and then point your kubectl to that cluster, and then Scaffold would start deploying your applications to that cluster. So you do not need a managed Kubernetes cluster in the cloud, or you do not need a production like cluster. You can nowadays a lot of tools and technologies are available for your developer. They can run a cluster all by on their laptop. And the best part with Scaffold is that the developers does not really have to go through the complexities of Kubernetes. For example, you assume you are a DevOps SRE who developed this scaffold.yaml file and also the necessary Kubernetes manifest, and you just put them inside the source code repository that the developer uses. So and for a developer, I mean, all he need to do in order to initiate the project, he execute the scaffold dev command on his laptop without having to worry about anything else. He run that command and he keep on doing his code, and as soon as the code get finished, Scaffold would give them a new preview URL of the code change that they did after deploying the application to the Kubernetes cluster. So that way you can actually easily make things much easy for your developer. They don't really have to go through the complexities of Kubernetes. A single scaffold dev command will set up their project from the scratch on their laptop. Awesome. And that's not just that. I mean, just think about how you can extend the control of the developer. So now the developer have the ability within their laptop, they can make the code change, and before they even commit the code change to Git, they run a local workflow within their laptop and see the preview of the applications, and it can be extended much further. Assume you are a company who want to give more control to your developers. For example, your developer need to have the ability to make some changes to the Kubernetes manifest. For example, you want to scale your applications, you want to change the number of replicas, or you want to enable the ingress, or you want to enable a horizontal pod autoscaler, or you might want to enable different resources, or make some changes to the resources that you currently have. Then probably you can use tools such as Helm, Customize, which you are probably already aware of. If you are not aware of these tools, can actually simplify your Kubernetes configurations. And basically, if I take the example of a Helm, you can package your entire applications, the Kubernetes application manifest, into one single Helm package, and then create a values file to customize your application the way you want. For example, you give your developers a single file, a values.yaml file, which they don't have to go through the complexities of Kubernetes or syntax of Kubernetes. They can just write lines such as number of replicas equal to 10, or auto scaling to be enabled equal to true, then number of replicas, or the image tag, anything they want to change, they can change it in a simple YAML file without understanding Kubernetes, and they can still integrate this tool with Scaffold. And for that, I can quickly show you another scaffold.yaml file, and this time I do not have a Kubernetes manifest, plain Kubernetes manifest. Instead, what I have is a Helm chart. So and if I quickly show you my VS Code, this is how it looks like. And in the previous example, I had a K8s folder and a bunch of Kubernetes manifest, but this time what I have is a Helm chart of my front-end application. And then what I also have is a values.yaml file, which is a very easy to understand file for my developer. If they want to change my container image, they can change it right here without understanding Kubernetes. They want to create a service account in Kubernetes, they can set this button to true. They want to enable ingress for the application, they can set ingress enabled equal to true. They want to adjust the CPU and memory of the application, they can just modify these values. And what they are actually doing, they are actually changing the configurations in Kubernetes without having to worry about Kubernetes. And then you ask Scaffold, and Scaffold to update the image to the latest versions before you run the applications in the local Kubernetes cluster. And so you can see the Scaffold look more or less same as the previous one, but this time Scaffold is using Helm to deploy your application to the Kubernetes cluster, overriding the image with the latest one which Scaffold has just created using Docker. So that is possible. So a combination of Scaffold and Helm is a great way to give a lot of control to your developers on adjusting your application setting, both the application settings and the developer workflow in Kubernetes. And this is great. So, and now the next part is, that's it. Next part is right here, and this is an extended scaffold.yaml file where we have more than one project. There is a front-end project and there is a front-end Helm chart, and then there is a backend project which has a backend Helm chart, and the backend project has necessary code and the Docker file. The front-end project also has the necessary code and Docker file, and both of them are built into a Helm chart. And you can see the Helm chart in these folders, backend chart and front-end chart. So I will quickly show you my VS Code so that you will get a better understanding. Over here you have a backend folder, and that consists of the backend Docker file along with all the source code, and then you have the front-end application with a Docker file, and then you have the front-end chart that is nothing but the Helm package of Helm chart of your front-end application, and this is the Helm chart of your backend application. And then you are using a scaffold.yaml file to list down the applications that you want to build, and also the applications that you want to build, and the way how you want deploy, and the way how you want to deploy. You want to deploy using Helm, and these are multiple releases that you want to create. This is the front-end release, and this is the backend release, as you can see. And then over here these are the different images that you want to build, the front-end image and the backend image, and over here you are deploying them to Kubernetes using Helm. And again you are port forwarding them, automatically port forwarding the applications to different ports within your local. So this way you can actually, if you are developing microservices, you have too many services that your developers are developing, you can list them all together in one command file, and your developer can adjust the configurations the way they need to adjust, right? So all these flexibilities come along if you are using Scaffold with Helm, and this is an awesome combination for your developers. Most of the things they can control by themselves, even including the Kubernetes configurations, right? Great. Now Scaffold may also be integrated with your existing many other tools. If you, all right, so before we go there, I also want to talk about the multi-stage Docker file, which you must use because it's a terrific combination. Using Scaffold with Docker multi-stage is a terrific combination, and I will tell you why. I'm sorry, give me a second. Sorry, that was my son. So the next thing is a multi-stage Docker file. So probably this is the most underutilized feature of Docker by many people, right? Basically, you can do a lot of things using Docker file. When you develop your Docker file, you can develop stage by stage. You can do the code review, you can do the testing, you can do the security scanning, you can do build process. A lot of things you can do stage by stage. The advantage here is that a lot of things will happen when you execute the Docker build command or when you develop your container image, a lot of things happen at once, and that would give a lot of feedback to your developer. And then use a scaffold with a Docker multi-stage file. So instead of a simple Docker file, use Docker multi-stage file with scaffold. Then developer get a lot of feedback as soon as they develop the code change. They don't just see a preview of the application, they can see a code review report, build report, test report, security report, everything within their local. That would be awesome, right? So that's a multi-stage Docker file with scaffold is an awesome combinations. So just do that, and that would help your developers a lot. And what I have shown is a simple example of a Docker file where I am doing only 2 steps. In the first step, I have a front-end project which I am building using npm. I am building the project into a folder called build, and then in the next stage I'm creating a production optimized image by using nginx as the web server and copying my front-end applications to nginx. And scaffold can also be integrated. And today I had used a Google Cloud Managed Kubernetes cluster to demonstrate, but scaffold can work on any Kubernetes cluster, and you can switch the context the way you want. And in a laptop, if you do not have a cluster that you in your company, or your company don't provide, cloud clusters are costly, right? I mean, you can probably, instead of creating a cluster in the cloud, you can create a local Kubernetes cluster in your laptop using kind or K3D, and scaffold can continuously deploy. The only thing scaffold look for is kubectl is pointing to the right context. Just scaffold uses kubectl to deploy the Kubernetes cluster, whichever it is, right? It doesn't matter. So it could be the one in the cloud, or it could be the one in the local. It's a great idea. Developer might want to use kind or K3D on their laptop to do the Docker development. And then you can same workflow you can develop, put inside a Jenkins server. If you have a CI/CD system or a Jenkins server, you can just put the same workflow, or the scaffold dev command or scaffold run command is a one-time command which will do everything that scaffold dev do without monitoring for the code changes. So you can use that in your CI/CD system, integrate it, and then it will work very well or there, right? So those are different things that you are capable to do using scaffold. And just whether you use, there are alternative tool also for scaffold. You can use Tilt or DevSpace. There are different cloud native tools available today that can help you automate the local developer workflow. So you can use any one of them. It doesn't really matter much which one do you use. You can just keep on exploring about the local workflow tools, but it is important that you have one, or your developer use one of these tools to automate their workflow. And yes, it has to be a combination of the tools, and just make sure that your developer don't have to go through a lot of headaches, and also make sure that this process happens very fast. You use Docker caching very efficiently. Use Docker multi-stage, use Docker caching very efficiently, so that the build process should complete within seconds, or in certain cases it can go up to a couple of minutes, not more than that. So developer would actually use them, right? So, and also avoid developer having to go through all the complexity. You can develop the scaffold YAML or whatever necessary files that the developer need, put them in a Git repository and give them, and they can just clone everything from the Git repository, and with a single command they can start this whole process on their laptop without having to understanding scaffold or understanding Kubernetes or nothing. They can just start without much effort. So try to do that, and hopefully, yeah, that's pretty much I wanted to talk about. And thank you. Bye bye.